테스팅 테스팅. 송철은 안 들어가는 걸로요. 예, 테스팅. 하나 둘 셋. 테스팅.
예.
Good morning, ladies and gentlemen. I am Hong Sung-soo from Seoul National University, and I'm also the vice chair of KSAE. I would like to officially declare the opening of the second Korea-UK Future Mobility Conference. We held the first conference last year, and as you are well aware, Korea and the US, in the area of future mobility, the two countries have advanced technology and are leading the development of future mobility. The conference is designed to promote cooperation in the area of technology and business between the two countries. For this year, we have many leading companies from UK presenting at today's conference. And it's a good opportunity for Korea to learn about the latest related technology development. We will be able to better understand the trends in future mobility, as well as the ongoing research that's currently happening in the US as well. And also, we're going to talk about the transition to future mobility. What would be the successful business models and strategies, and how can our two nations cooperate? And that's the main topic that the panelists will be discussing. This is being broadcasted live on YouTube. We have Korean and English simultaneous interpretation provided, so I'm sure that we will not face any language barrier today. So I'd like to briefly introduce today's conference, and I would like to also invite Simon Smith, British Ambassador to Seoul, to deliver his welcome speech. Simon Smith has been the British ambassador to the Republic of Korea since 2018, so for 3 years. And prior to coming to Korea, he has been working at Kiev, Vienna, Tokyo, and Moscow. And so without further ado, we would like to invite Ambassador Simon Smith to deliver his welcome remarks. Thank you.
Hello everyone, I'm Simon Smith, the British Ambassador to South Korea.
It gives me great pleasure to welcome you all to the Korea UK Future Mobility Conference. I'm delighted to have the opportunity of addressing the conference following the success of last year's inaugural event. My particular thanks once again go to Professor Hong Song-soo at the Seoul National University and Robert Evans, the CEO of Cenex, who both worked closely with my team at the British Embassy to enable this joint conference. The UK and Korea lead the world in connected and automated mobility, CAM, and today's event will showcase the new technologies and business models that will change the way we use vehicles in the future. The shift to connected and autonomous vehicles, or CAV, is going to be one of the biggest transitions of the industrial age. Put simply, CAVs are set to transform the world by fundamentally altering the way people and goods are moved and deliver significant positive impact for the environment, transport users and businesses. They have the potential to improve safety on our roads, reduce congestion, create jobs and increase productivity. Collaboration and partnership will be essential for the successful development of future mobility. The UK is a world leader in self-driving vehicle innovation. It's currently ranked second in the G7 for self-driving vehicle readiness, excelling on policy, legislation and cybersecurity. We're also home to some of the most exciting automated mobility companies in the world who are setting the standard for global innovation in this space. The UK market alone could be worth as much as £42 billion by 2035, with the creation of approximately 38,000 new jobs. The UK government has worked closely with industry and academia to harness the potential of connected and self-driving technologies. To date, the UK has created one of the most welcoming regulatory environments for self-driving technology, as well as jointly investing £400 million with industry into cutting-edge British innovation and establishing the £200 million CAM testbed UK ecosystem, where companies from around the world can test technologies safely. The connected and self-driving vehicle market is expected to grow rapidly in both Korea and the UK, and there's no doubt that CAM technologies will help enable us to meet the challenges of tomorrow. And of all these challenges, climate change is unquestionably the most serious. Emissions from road transport now account for over 10% of the global total, a figure which continues to rise as the global vehicle fleet expands. In the last 5 years, we've seen remarkable growth in the global sales volume of new electric vehicles. In 2020, the sale of EVs in Norway accounted for 54% of all cars sold, eclipsing internal combustion engine sales for the first time. In the UK, we currently have around 300,000 pure electric vehicles on the road, a number which is growing rapidly and which adds to the nearly 600,000 plug-in hybrid vehicles already on UK roads. In the 100 years since the first commercially successful internal combustion engine was developed, the cars we use have grown steadily faster and more powerful. Until recently, however, manufacturers have struggled to develop cars which don't damage our environment. And we need to be clear that despite the recent uplift in the sales of zero-emissions vehicles, the vast majority of the cars sold globally are still ICEs. As of right now then, our mobility continues to be dependent upon the technology of the 20th century. This simply has to change. Over the course of the next decade, we're likely to see more innovation in this sector than in the last 100 years combined. This automotive revolution will be driven by the absolute necessity to tackle climate change before it's too late. If we fail to achieve this, no country will avoid the impact of further global temperature increases. The UK has set the world's most ambitious climate change target into law, seeking to reduce emissions by 78% by 2035 compared to 1990 levels, taking the UK more than 3/4 of the way to reaching net zero by 2050. Last year, the UK's Committee for Climate Change advised that a 2032 ban on the sales of new ICEs was essential in order to achieve 2050 net zero. Following this, the UK government announced that the sale of new petrol and diesel cars in the UK would end by the earlier date of 2030, putting the UK on course to decarbonise cars and vans faster than any country in the G7. And the world's biggest car markets are following our lead. The EU's Fit for 55 package effectively bans the sale of internal combustion engines after 2035. And the US has now committed to 50% of all new cars sold by 2030 being zero emission. Ultimately, the UK believes that a ban on ICEs will not just be good for the environment, but also for our wider economy. Our own experience demonstrates that it's possible for green growth to accompany economic growth. Since 1990, we've grown and decarbonised our economy faster than any other G7 country. We've reduced our greenhouse gas emissions by 43% while growing our GDP by 2/3. We've done this by providing initial regulatory support whilst also setting out our decarbonisation ambition in law through the UK's Climate Change Act. Decarbonisation is not just something we would like to do, it's something that we legally have to do. And this legal requirement provides long-term policy certainty for business and enables them to make the right investments in the future. In a little under 2 weeks from now, the UK will host COP26, the most important meeting of the parties to the UN Framework Convention on Climate Change since the Paris Agreement of 2015. One of the key messages will be that global green growth simply must underpin our COVID-19 recovery. A back to business as usual approach would be a pathway to disaster. As we face the challenge of climate change, we have the opportunity to turn an existential risk into the greatest commercial opportunity of our time. And at COP26, we're asking all governments to work towards all sales of new cars and vans being zero emission by 2040 or earlier. We must deliver strong and coordinated action to facilitate the transition to zero emission vehicles. This will allow us to scale up the production of zero emission vehicles, increase economies of scale and drive down the cost of battery and fuel cell EVs, and ultimately quicken the pace of transition to electrification. But we'll only achieve this by working together. South Korea has committed to achieving carbon neutrality by 2050, and through policies such as the Green New Deal, is now exploring digital, environmental and social reforms to achieve net zero and support Korea's recovery from COVID-19. I'm excited by the growing collaboration between the Korean and UK automotive industries. Last year saw Hyundai Motor's £84 million investment to UK electric van maker Arrival. We've also seen an MOU between Hyundai Motor and Ineos to explore new opportunities in Hyundai fuel cell systems and LG Chem's supply of battery packs for the Jaguar I-Pace. In the coming years, the automotive sector will help to deliver transformations which will forever change the way that people live, work and travel. How we accelerate this transition is then one of the most pressing issues in modern transport. The UK's automotive relationship with Korea goes back many years. Working together now on the technologies of the future can only bring further success. Thank you and enjoy the conference.
예, 사이먼 대사님 대단히
Thank you, Ambassador. I know that you're very busy, but I could hear the passion and the encouragement you have on our topic. The conference will begin at 10 o'clock, so we do have some time before the official program begins. And so I'll just take this opportunity to give you the background to this conference. This conference is currently co-organized by KSAE System Software Section, as well as Cenex and also the UK Embassy in Korea. So we get funding from the sponsors and we offer the conference free to the audience. We aim to talk about the technology development and business strategy development between our two countries. And we want to promote business cooperation, collaboration between Korea and the UK. So representing Korea, myself, and also representing UK, we have Cenex CEO Robert Evans being the co-organizers of this conference. And we also have many members in the program committee from DGIST, Jiwon Choi, from KT, Kangnim Choi, from SNU, Seoul National University, Professor Young-Sub Ju, Korea University, Professor Yongshin Kim, and also from British Embassy Seoul, Ji-young Lee, from SNU, Professor Hyun-Seok Ryu, and also from SMMT, David Wang. They have participated as members of the program committee. Last year, we had the time difference between Korea and UK, and we started the conference in the late afternoon Korea time, and it was very difficult for Koreans because we had to stay very late until the end of the conference. This year, as we are actually using Korea's daytime as the start time for today's conference. And we have an opportunity to better understand the technology development taking place in the UK. So to talk about the first session, we have 4 speakers and the time is from 10 to 12. So we have as a first presenter to look at an overview of what's happening in the UK. So to talk about the future trends, future outlook of the UK auto industry, and also to talk about the R&D activities that are taking place from the public and private sectors in the UK. And also from the Korean side, we have representatives from the Korean industry, and also we will have a presentation to talk about Korea's V2X strategy as well. So through the first session, I think that this is going to promote the better understanding of what's happening in our respective countries. And then we will have a lunch break, and session 2 will begin from 1:30 till 4 p.m. and we have leading UK companies participating in session 2. We are very happy to have prominent speakers delivering presentations and to talk about what's currently happening in their area of expertise. And then the third session will be the panel session. So starting from 4:20 p.m. till 6 p.m., we are going to talk about the service and business models for future mobility. And so we have invited 7 academics to serve as panelists for this session. So we will have many meaningful discussions taking place in our afternoon session as well. So that was a rundown of today's program. I think that we have 3 minutes to use as a short break, and then we'll begin once again officially session 1 at 10 o'clock. So please don't go away too far. And as you know, we have the YouTube broadcast, and so if you move the bar in the low bottom section of your screen, you'll be able to select the presentations that possibly you have missed as well. So I hope that you are able to enjoy the technology as much as possible. Thank you, and I'll see you shortly. Ladies and gentlemen, I am Song Soo Hong, professor of Seoul National University, and I would like to officially declare the opening of session 1 from 10 o'clock to 12 o'clock. We will have 4 speakers presenting for 30 minutes. As you are well aware, we're still under a COVID pandemic, and so the 2 UK presenters were not able to come to Korea. They did, however, send us pre-recorded presentation, which we will play to you at this conference. But of course, you can pose your questions in the chatting section of YouTube so that we can relay those questions to the speakers in the afternoon's panelist session. Without further ado, I would like to begin session 1. And as I have mentioned in my opening speech, we'll be looking at the market, industry, and technologies for future mobility. We aim to have a better understanding of the current trends and current status of the R&D and technology development in Korea and UK. And we have, as for our first speaker, David Wong from SMMT. And SMMT is just like a private organization that we have in Korea, which is Korea's automakers industry. And SMMT stands for the Society of Motor Manufacturers and Traders. And so 800 or so OEM suppliers and other related stakeholders are members of SMMT. And David Wong is the senior technology specialist and has been working as an interface, a bridge connecting SMMT to the industry and the market. And we also have a brief introduction of David Wong, who is the Senior Technology and Innovation Manager at SMMT. And he's going to talk about the current analysis and future outlook of UK auto industry.
Korea UK Future Mobility Conference. I'm delighted to give a presentation on behalf of the Society of Motor Manufacturers and Traders UK. The SMMT is UK's automotive industry body, representing the sum total of UK automotive, including all major vehicle manufacturers, automotive suppliers large and small, technology and engineering firms, the automotive aftermarket, as well as a number of automotive, auto tech, and mobility startups. I'm going to talk about some key trends seen in the UK automotive today: electrification, automation, and connectivity. I'm going to touch very briefly on the state of play and give our views on what the future outlook may be. Let's start with just a brief glance at UK automotive as a whole. And you'll see that these figures are actually from last year, which was, of course, a year that was ravaged by the effects of the pandemic. And every sector felt it, including automotive. And just a year before, in 2019, for example, UK automotive industry turned over £79 billion, registered about 2.3 million cars, as well as manufactured 1.3 million cars, 80% of which were exported. And hopefully, things will get better soon, certainly if not this year, obviously as the semiconductor issues. Hopefully, if not this year, then from next year, we'll see a rebound in most of these figures. Let's dive very quickly now into the first trend, which is the elephant in the room, electrification. Good news is that EV registrations are on the rise. Last year was the coming of age of plug-in cars in the UK. For the first time ever, the UK recorded plug-in car market share of more than 10%. So the 10% is a very important one because it signals that things are going to go up and up and up from this point henceforth. So if you don't believe it, look at the figures in the first 3 quarters of the year. Between January to September this year, the market share for plug-in cars has already breached 16%. And all being well, between now and the end of the year, we think the market share will probably stay between 16 to 20%, which augurs well for the transition to zero-emission mobility in the UK. Thanks to industry commitment and investment, the industry has been investing heavily over the last few years to bring an increasing number of electrified models to the market. Now, currently in the UK, about 1 in 3 models available are actually electrified vehicles. A quarter of them are actually plug-in or fuel cell models, and 1 in 10 are battery electric models. Now, the number of manufacturers, particularly in Europe, have already confirmed that their brands will be fully electric between 2025 and 2030. And we think the investments will go up. Certainly the government's own 2035 end of sale delivery plan suggests that manufacturers will invest collectively an estimated £230 billion in the next 5 to 10 years. The outlook is absolutely bright, and the trajectory is going in the right direction. It's only one direction, and it's up, up, and up. You may already know that the UK government has an end-of-sale policy for non-zero emission new cars and vans by 2035. And we think the market share for battery electric cars will probably reach about 25% by 2025. And by the end of this decade, it should be about 71% before inevitably it will become 100% by 2035. But this positive market outlook is predicated on a very important assumption that infrastructure expansion, charging infrastructure expansion, keeps pace with the upsurge in electric vehicle uptake. As we have seen in the last year or so, the ratio of plug-in cars to public charger have actually deteriorated in the UK. And we need to ensure that this is reversed. We need to ensure that the rollout of charging infrastructure keeps pace with what is likely to come. And what's likely is that you'll see a continuing upsurge in battery electric vehicle registrations in the UK. Move on to the second and third trends, automation and connectivity. I'm not here to talk about our testing and trialing ecosystem, and that's because there are other speakers on this conference who will expound on this topic much better than I can. Suffice to say that thanks to government investment and initiatives in this area, including more than £250 million of public funding in the last 6 years or so, we now have a world-class testing ecosystem in the UK. And also complemented by a light touch approach to regulation that the government has adopted. I'm not here to talk about ADAS either, but suffice to say that from our registration data, it is clear that an increasing number of new cars available in the UK market are available with ADAS. And 71%, for example, actually have autonomous emergency braking available either as standard or optional equipment. And I do not need to convince you about the benefits of ADAS, particularly in mitigating the risks of pollution. I'm here to talk about automated vehicles, and more specifically, automated driving systems. Where we are today. So the UK has decided to approve of the automated lane keeping system, which is as a level 3 conditional automation, as an automated driving system for UK roads, provided that manufacturers bringing ALKS into the UK market seeks approval from the Vehicle Certification Agency, and provided the automated lane keeping system that is meant to be deployed in the UK is confirmed to be compliant with GB traffic laws. Yeah. Because deployment is hugely dependent on both international and national traffic regulation. And quite a number of the jigsaw pieces are coming together, both in terms of the liability framework which we already have by way of the Automated Electric Vehicles Act 2018, as well as the changes to the Highway Code, which should be tabled in the UK Parliament in a matter of weeks, as well as public communication where government and industry work together to educate the public on automated driving systems and the safe use of the systems, as well as data sharing with insurers in the event there is an accident. So level 3 should imminently be deployed in the UK. However, the future is more exciting than just level 3. But when we talk about automated vehicles, we tend to confuse and conflate automated driving systems fitted in passenger cars with those that are basically like robo-taxis and automated delivery and freight. Let's be very clear that there are 3 main applications when we talk about automated vehicles. The easiest is probably the vehicles that we know today, the passenger cars, which today may be fitted with ALKS. Now, not every manufacturer will do it. Some manufacturers may choose to skip SAE level 3. But for those who are doing SAE level 3 today, tomorrow there may be quite likely a more sophisticated version of ALKS at full highway speeds and ability to change lanes. And this will quickly morph then into SAE level 4, perhaps first on the motorway, followed by urban areas. But one use case that could be deployed even sooner than SAE level 4 urban ODD is basically automated valet parking, which has already been demonstrated in a number of locations in Germany. But those are for the passenger cars, which we know very well. We then have to talk about automated passenger services, which is different because it is truly driverless in the sense that there is no onboard safety driver, likely with remote operation. And these are invariably SAE level 4 applications. They may assume different form factors. They may be shuttles for urban services. They may be ride-hailing cars, but obviously without an onboard driver. Or they may be urban or interurban, slightly larger shuttles or even full-scale buses. And quite a lot of these have already been trialed or currently being trialed and demonstrated in the UK. And then there is the automated delivery logistics use case, where similarly, there may not be an onboard safety driver, particularly if you're talking about urban or last mile deliveries. But there is also the interurban or port to hub or hub to depot type of logistics vehicles, which sometimes may have an onboard safety driver for parts of the journey. And finally, there's also the specialist logistics use case or off-road use case, such as airport dollies, which obviously will not have a safety driver. Now, there are many types of use cases within a single application. But a lot of these, again, have already been trialed or are being trialed in the UK, and we think it's quite positive. The future looks positive, and we think quite a lot of these could be deployed, provided we overcome a few more challenges. The challenges I'm talking about are basically the remaining 20% of the challenges in developing and deploying automated vehicles, because the first 80% of challenges, in my opinion, have already been solved. But the remaining 20% are proving to be the most intractable and the most difficult to solve. And these include technology challenges, accounting for as many edge cases as possible, developing high fidelity, high resilience systems to an acceptable level of safety for the society. But even if you have the technology challenge, which is an engineering challenge, you still have to ensure that regulation keeps pace and regulation is fit for purpose, which is what the UK government is currently doing with its regulatory reform, following the Law Commission's 3-year regulatory review program. And if you crack the technology and regulation challenge, there's also the challenge of then gaining public acceptance, educating the public, and basically making the public comfortable in riding in one of these vehicles. Yeah. So inculcating the right social behaviors when these vehicles coexist with legacy vehicles on the road. And finally, it's a small matter of ensuring that it makes economic sense to deploy automated vehicles, whichever applications we're talking about. Yeah. Is to ensure that all the actors could actually make it work for themselves and society as a whole. And there has to be the right business model. Let's go to the final trend, which is basically connectivity. In the UK currently, those in blue are the connected vehicle services that are already widely available. and those in amber are likely to be available quite widely very soon. However, the impediment to delivering these services to a level of user experience which is satisfying, which is acceptable to most users, is basically network coverage, a signal on the road. And we're talking about not just motorways, but 247,000 miles of Great British road network. And at the moment, about just over half of the 247,000 miles of British road network actually have full 4G and LTE connectivity. Worse still, 2% actually have no network coverage at all, not even 2G. And this is where eCall, the mandated eCall, is useless. We're excited about the future because we think one of the more exciting things that we could see deployed quite widely in the next few years is this concept of software-defined vehicle, where manufacturers offer over-the-air software update to deploy a number of new features and new user experiences. Like our smartphones today or our tablets benefiting from over-the-air software updates. And manufacturers may, in gaps of perhaps every 9 to 12 weeks, offer new updates that will give you a completely new experience of the car. And in some circles, it has even been touted as having something like a new car every 9 to 12 weeks. And this means the vehicle increasingly becomes the platform. The vehicle as a platform shouldn't be ruled out as a norm going forward. What this means is car is increasingly become something that you can servitize. And it doesn't take much to imagine that the car could be horizontalized as a platform to include services straddling a number of verticals that previously had very little to do with automotive. So, for example, smart appliances, retailing smart payment, and the connected home. In the past, they are quite distant from automotive in terms of being verticals in their own right. But with car as a platform, we can bring these verticals together ever closer to the customer. And secondly, certainly in Europe, to find the right format and the choice technology going forward. And what I'm referring to is that until today, it has never been sorted out, this tussle between cellular V2X and 802.11p as the technology of choice for short-range connectivity. And then you may be asking, where's 5G in all of these? And 5G certainly has its own use cases: automated driving, live real-time refresh of the layering of high-definition, high-precision maps, and as well as services that will involve AR, VR, and video on demand. However, a lot of the connected vehicle services that I showed you in the slide just now are already available and could adequately be deployed on LTE alone, provided we've got decent coverage on the road network. So 5G is still in search of its killer use case, not just in telecoms, but even in automotive. Finally, while we're talking about all these future technologies, it's worth looking at a legacy technology, which is 2G, 3G, appreciating that the networks carrying 2G and 3G will be switched off at some time this decade. And in some European countries, they have already been switched off. Now, the 3G switch off is not so much a problem because we know for a while already that 3G will be refarmed for LTE and 5G. But 2G is more complicated because it forms the basis for the mandated, the regulated eCall, not the private SOS of eCall. This is the regulated eCall, both in European Union as well as the transposed laws into the United Kingdom after Brexit. Yeah. And this is based on 2G technology. And our estimates suggest that by the middle of this decade, there could be about 11.5 million cars on UK roads that will have eCall based on 2G technology. Second area is telematics and connected vehicle services. And we think about something like 6.5 million cars could be on the road in the UK by the middle of this decade with 2G, 3G based model offering telematics and connected vehicle services. And these are, of course, circuit switching hardware. And smart metering for smart charging certainly could also be affected because the smart meters in the UK, for large parts of the Midlands down to the south, are actually based on 2G, 3G hardware. So the 2G, 3G switch off, if poorly planned, may present some challenges to these areas that I have highlighted. However, by saying that the future is interesting and the future is exciting, with electrification, with connectivity, and with automation, we think the whole automotive industry is experiencing change. And the change is for the better, and the change is exciting. There's no reason to fear the change, and in the UK, we are embracing the change. Thank you.
예, 지금까지
Thank you very much. We heard from David Wong from UK's Society of Motor Manufacturers and Traders, and we heard about various issues that the auto industry of UK is interested in, and also about future mobility. And I think it was comforting to hear that they have many challenges similar to ours. And we heard about the unique industry and also research areas of the UK. If you have any questions, you can write down your questions utilizing the YouTube chat function. While listening to the presentation, I feel that the software-defined vehicle can come out, and every 12 weeks we can experience a service that makes us feel as if we are driving a new car. And Korea is a country that needs to build up software capabilities. Therefore, I think we need to strengthen our efforts in this field. And another important area
자동차를 검증하기 위한 시뮬레이션
is simulation and virtual development environment creation for building an autonomous vehicle. So as we move toward software-defined vehicles, we see some defects in softwares, and we need to eliminate those defects, but real car testing and the costs associated with such testing can be a barrier, and virtual testing and simulation can be an effective tool to respond to those challenges. And I think the UK is leading in those areas. While collaborating with the UK engineers, I feel that Korea is working on synthesizing, and UK engineers put emphasis on analysis. In particular, simulating and analyzing against hazards that are related to passengers, and UK companies and research centers can be partners for Korea as we go forward. I think it is time for us to go on to the next presentation. Then, the second presentation will be on connected and automated mobility R&D trends in the UK auto industry, and the second presentation will be about these R&D trends. And when you are focused in your own research area, you might feel that you're the only one researching that area. So you may become curious about what others are doing and what types of research is being done in other parts of the world. And you wonder if what you're researching and whether your concerns are concerns shared by other engineers and other researchers around the world. So next, we will be hearing from Ricardo, which is a research and consulting leading firm in the UK. And Michael Bell will be delivering the presentation. Michael Bell is Group Strategy Director at Ricardo PLC. and he has experience working in various auto companies. And he received his bachelor's degree and doctor's degree from University of Liverpool. We will now listen to the presentation of Michael Bell.
Good morning. My name is Mike Bell. I'm Group Strategy Director at Ricardo plc. Today I'd like to cover the connected and automotive R&D trends in the UK automotive industry. My focus in Ricardo is on future mobility and sustainable energy technology. I've been with Ricardo for 2 years. Prior to this, my background is cross-sector and includes 11 years in automotive, 7 years in software, and 8 years in engineering and utilities. In terms of the agenda today, I'd like to start with an introduction to Ricardo. Then we'll cover why the UK is a key location for CAM innovation, starting with Ricardo's CAM offerings and then giving you a flavour of the CAM capability in the UK. Ricardo was founded in 1915 by Sir Harry Ricardo. From our automotive roots, we were developed into a cross-sector engineering, environmental and strategic consulting company. We particularly focus on the intersection of mobility, energy and environmental impact. Our vision is to create a world fit for the future. Our engineering expertise covers decarbonising future mobility, access to clean air and water. This includes the impact of mobility and Our engineering expertise covers decarbonising future mobility, access to clean air and water. This includes the impact of mobility in industry on the environment. We help our clients achieve their net zero goals. And last but not least, we provide expertise in safety, assurance and certification for multiple areas of transportation. Ricardo works across 4 key markets. Our breadth of capability starts with policy support for governments and NGOs, defining strategic plans for our clients, to developing engineering solutions from initial concept to complete production delivery. Let's look at our sectors. Automotive remains our largest sector, and we cover two-wheelers, passenger cars, through to heavy-duty transport and off-highway vehicles, together with motorsports. Rail and mass transit is a growing sector, specifically focused on systems engineering, safety and assurance work. There is now growing synergies around cyber and functional safety between automotive and rail. We also operate in defence, principally around vehicle safety, fleet management, together with communications and cyber security. And lastly, energy and environment, our fastest growing sector. We help governments as well as industry clients to solve a range of challenges, including the impact of climate change. Specifically in the automotive sector, we also help with life cycle assessments for OEMs and Tier 1 suppliers. Let's now look at what makes the UK a key location for innovation in connected and automated mobility. There are 3 key pillars of capability in the UK which come together to create the right environment for innovation. A leading tech industry, CAM moves the focus to software and electronics from mechanical engineering. The UK is very well placed, and our sector is both well renowned and has grown in spite of COVID. A diverse, high-value automotive sector, our product range covers many areas of automotive, from niche to volume manufacture. This is particularly important as CAM is not just about passenger cars. The final pillar is our proactive government support, creating the right environment and infrastructure to make it attractive to CAM developers. We have forward-thinking legislation, robust frameworks for vehicle trials, both on public and private roads. The UK government has also fostered collaboration through R&D funding. Let's take a look at the UK tech sector. As I mentioned, the importance of software, electronics and semiconductor design is paramount to CAM. We're seeing many of the tech skills highly transferable and necessary for CAM. A few important facts to help understand UK tech. UK tech venture capital investment is the third largest globally. With the fastest growth in deep tech investment, this includes areas such as CAM and artificial intelligence. The UK is an attractive location for overseas investments, with 63% coming from overseas. We have a startup and scale-up ecosystem valued at £585 billion. Hopefully this gives you a useful indication of why this sector matters. I mentioned the importance of the role of government working in partnership with industry and academia. The UK has a dedicated government office, the Centre for Connected and Autonomous Vehicles, or CCAV, which was set up in 2015. We were very quick to recognise the significant benefit to the UK economy of CAM. CCAV focuses on the shaping the future of safe and secure CAM. Significant public and private investment has been made. A critical aspect of CAM is having the right environment to be able to test and trial vehicles. Zenzig was created by the UK government and industry to focus on key areas of UK capability in the CAM sector. We now have a CAM testbed of 8 sites, including both public and private roads and facilities, all within a 3-hour drive of one another. We can address many of the unique CAM challenges, especially around the benefits of 5G communications for V2X communication with dedicated private networks. Finally, the UK Research and Innovation Organisation, via Innovate UK, which provides collaborative funding, often jointly with CCAV, to facilitate collaborative R&D in CAM. With numerous successful programs, some of which are currently active, such as the Project Endeavour, with multi-location pilots designed to accelerate and scale the adoption of autonomous vehicle services across the UK. For many years, Ricardo has operated in the CAM space. Our work covers strategy in terms of new entrants and engineering services, together with project support for autonomous pilots. Let's cover these capabilities in more detail. We help a variety of clients with strategy. Our clients range from venture capitalists to private equity investors, tier 1 and 2 suppliers, and OEMs. We've supported clients with market entry strategies and business models for growth. Recently, we undertook a study for a LiDAR supplier in terms of business model and entry timing. We've supported numerous tier 1 and 2 suppliers and OEMs with technology roadmaps, together with service offerings. We've done this for several Japanese OEMs recently. We have undertaken modelling and analysis work for CAM. Last year, we undertook a study for 5G-AA, the 5G Automotive Association, to help improve the understanding of the costs and challenges and opportunities of different communication technology approaches to vehicle infrastructure use cases. We've provided benchmarking services for OEMs to help in their component selection for CAM solutions. Let's look at our engineering offerings for CAM. So starting with vehicle engineering, we develop solutions from heavy-duty truck platooning, Level 2 plus ADAS features for passenger cars, and are currently working on the design of a mobility as a service vehicle in conjunction with World Auto Steel. Given our significant vehicle integration expertise, we are able to run complete programs, including component selection. Critical to CAM is functional safety, with experience of standards such as ISO 262, IEC 61508, ISO PAS 21448, MISRA, and Automotive SPICE, together with up-and-coming cybersecurity standards. Our third area of capability is in CAM project support. This covers areas such as safety support, human factors, independent verification and validation, and independent safety assessment. For safety support, we're looking at the specification, development, testing of CAM products, and that's looking at the entire life cycle and includes definition, hazard analysis, and risk assessment. For human factors, we're advising on user-centric design during the early stages of development and helping considerations for disabilities and other road user safety. Our independent verification and validation services help support projects throughout the life cycle to ensure requirements are captured correctly and delivered for all functional and safety aspects. And lastly, independent safety assessment. We can ensure that the CAM systems are assessed alongside international standards such as ISO 262, EN 50126. A good example of this kind of project was WePods, who were looking to develop the first self-driving electrified shuttle for use on public roads in the Netherlands. Ricardo was enlisted to address the safety cases of the shuttle, transporting up to 6 passengers between 2 Dutch towns. The shuttle needed to function safely in an environment where both pedestrians and other vehicles were present. Our safety assurance experts successfully delivered a safety plan for WePods. It included hazard identification sessions, FMEA and collection, coordination and communication of the safety evidence. This safety case combined the necessary evidence in a consistent and coherent way and aid the authorities to make a final go, no-go decision for the WePod shuttle. The UK has a strong range of CAM capabilities. I've grouped them into 8 main categories: producers of autonomous vehicles, software suppliers of virtual simulation and CAM datasets, together with real-world testing capabilities. The area of simulation is incredibly important as a way of repeatedly verifying and improving the operational design domains, or ODD, that autonomous vehicles must operate safely within. Communications and cybersecurity is critical for CAM, especially with the implementation of ISO 21434 for WP29 Vehicle Type Approval Regulation. Advanced geolocation. Depending on your approach to CAM, geolocation can play a critical role in very accurately positioning of vehicles. The integration of smart cities infrastructure and other forms of mobility is an important piece of the CAM jigsaw. Data exchanges enable numerous CAM use cases to be monetized, and we have a number of software providers in this space. When it comes to sensor technology within CAM, computer vision and various sensors is a complex area of R&D, and we have a strong focus both in academia and companies. And lastly, we have companies providing the platforms, both software and hardware, together with the necessary sensors to realize CAM. To help give you an idea of some of the CAM R&D innovators, both commercial and academic, I've provided a number of examples. Hopefully it provides a useful snapshot of the capabilities you'll see in the UK. You'll hear from several of these companies today. We have also many overseas companies working on CAM R&D in the UK, which I've not shown on this slide. So if we start with autonomous vehicles right at the top, Riga have a number of vehicles from a 10-person shuttle to pods and remote supervised surveillance and intelligent patrol vehicles. They also provide technology stacks around autonomous control systems and fleet management and tracking. Street Zone provide a lightweight, narrow electrified delivery vehicle, the Pixie. They also provide autonomous software for the Terberg autonomous truck in conjunction with partners Nokia, Hitachi and Voices. For simulation, there are a number of companies using software and hardware solutions. Canopy Simulations have taken their motorsport software simulation engine and developed Canopy Copilot to handle control in unusual autonomous situations. Simulation CGA comes from a virtual simulation and game development background and have developed bespoke simulations to develop smart city road networks and autonomous driving solutions, including IR, LiDAR and radar sensors used by autonomous vehicles, accurate traffic flow models interacting with the 3D city, and optimal environments which can be viewed virtually or in mixed reality. CAN Engineering provide advanced simulators, extended reality and advanced modelling and simulation solutions to support both ADAS development and CAM development. AB Dynamics provide a range of physical simulators, physical test facilities, together with their Simpia software toolchain for simulation. The benefits of this means testing scenarios can be shared between all AB Dynamics testing systems across track testing, simulation and laboratory vehicle characterization and measurement tools. Myra, UTech Milborg and IADA Cavway provide physical CAM testbeds, including multiple services around these locations. Thatcham Research is working with Zenzik on consumer ratings to support the safe introduction, adoption and use of automated driving systems on UK roads, starting with automated lane keeping systems, or ALTs. For communications and cybersecurity, Cryptolab provides secure communications for critical infrastructure in a range of sectors, including their quantum random number generator technology. Angoka provides secure communication for in-vehicle and V2X communications. For geolocation, Helix Technologies offers precise antennas designed and manufactured to the highest specifications that enable CAM developers to create the smallest, most accurate positioning, navigation and time synchronization products. Albora Technologies provide two offerings: AlbaSnap, a precise geolocation product to better track and visualize assets or people in challenging or interference-rich environments. And the second product, AlbaSpot, an affordable geolocation cloud-based correction service that provides continuous high-precision positioning. For smart cities, Vivacity offers artificial intelligence centers and smart junction signal control gathered from anonymous data 24/7 on transport modes, traffic flow and traffic patterns, supporting strategic decisions to help optimize the transport network and improve urban infrastructure. One network allows you to coordinate and communicate right away activity in an intuitive map-based platform. Their tools allow you to share data across teams, jurisdictions and construction companies, also integrated with major GNSS providers to communicate road closures to the public. For data exchanges, Convex sits at the intersection between CAV, transport network operators and mobility service providers, enabling integrated mobility solutions that rely on data exchange. Synaptive offers a platform integrating with the connected systems and vehicles, as well as any installed telematics loggers. Ingested data is normalized and standardized and made available to their partners through their own API. Wejo provides an automotive data exchange, Wejo Adept, a secure, compliant and flexible platform for sharing and accessing connected vehicle data. For vision and sensor capabilities, Robok provides AI-based 3D vision optimized for low-power compute platforms with modular and scalable perception for object detection, classification and tracking. State-of-the-art accuracy for depth estimation from 2D images on embedded systems, and continuous and robust localization for indoor and outdoor environments. Fusion Processing is a provider of AV level 4 and 5 technology for autonomous buses using a range of driver assistance systems. From a platform perspective, Conidigital offers a number of capabilities, including ConiCav, a turnkey automated and optimized integration of CAVs into local transport systems. It utilizes AI and machine learning techniques to improve asset management, together with ConAV, which provides technology-agnostic vehicle automation solutions for flexibility, scalability, and upgradability. eTron Technologies provides L2 Star, a level 2+ ready ADAS software architecture, incorporating their automotive safe AI, which features Highway Pilot and DeepRL-based automated lane change. Barrow Vehicles provides vehicle robot platforms AI compute platforms, sensors and actuators for drive-by-wire autonomous vehicles. 5. Provide a platform for autonomous vehicle development and safety assurance. These include traffic jam, motorway and urban chauffeur capabilities. Oxbotica is working to build an ecosystem that supports the adoption of autonomous vehicles, building partnerships to accelerate the deployment of a universal autonomy. Selenium is a full-stack autonomy system, an on-vehicle suite of software which, given a drive-by-wire interface and very modest compute hardware, brings full autonomy to a land-based vehicle. Cesium provides an in-cloud fleet and data management platform. Oxbotica have partnerships with Ocado and ZF for autonomous pods. Hopefully today's presentation has given you a good perspective of what the UK has to offer. To recap, we have a strong technology and innovation capability from industry and academia, backed by the government support and frameworks for vehicle trials on UK roads. Our partnerships and collaborative R&D project cover all aspects of CAM: automotive OEMs and suppliers, software and hardware developers, data platforms, insurance and legal companies, together with mobility infrastructure providers. I mentioned our leading tech sector being critical to help foster and develop CAM. The combination of automotive engineering, software, AI, and semiconductor capabilities provides a world-class capability to build from. I appreciate you taking the time to watch my presentation. I hope you found it useful. Do not hesitate to contact me with any questions. Many thanks. Goodbye.
두 번째
Yes, we've just heard the second presentation, and Mike Bell delivered a very interesting presentation on connected and automated mobility R&D trends in UK auto industry. And so I think he introduced a spectrum of various interests and developments that are taking place in the UK. And I was very impressed with some of the slides that he shared with us. And I think we have many commonalities and differences. And so in the area of analysis and also software architecture, I believe that UK has a very fervent interest in these areas. And you just heard the technological and R&D trends in UK. Now it's time for us to look at the developments taking place in Korea. And we live in Korea, and we don't often get a chance to get a full 365 overview of Korea's auto industry. It's very fortunate that we have this conference because it serves as an opportunity for us to take the time to look at the Korean mobility industry. And the presenter for the third presentation is Joo-won Cha, CEO of Cha Mobility Research Institute. If you put your name on a company or institution, we normally believe that you take great pride in what you do. And CEO Cha has had very diverse experiences. He is a policy expert and futurist in the mobility area. So he has been talking about various mobility policies and future outlooks, and he's engaged in many different activities. He also has authored The Future of Mobility in 2018 and co-authored Job Killer, The Future of Jobs Changing by Robot and AI in 2016. And In 2002, he received his PhD in Human Factors for Vehicle and Automated Highway System at Aju University, and he has been an important policy advisor and research fellow in the respective area. And so we'd like to give a big round of applause to Dr. Cha. And the title of his presentation is Future Outlook of Korean Mobility Industry. Good morning. I am Ju-won Cha, and can I have my slides up? The title of my presentation is Future Outlook of Korea Mobility Industry, and I'm going to talk about various related policies in Korea and also to talk about the transition Korean companies, especially startups, are transitioning into the mobility area. And I'll talk about various business models, business plans, and also to talk about any possible challenges we may have in collaborating with UK. If we first take a look at Korean government's mobility policies, if you do research on policies, you would understand the hierarchy that is present for various policies. And I think what's overriding is the Korean New Deal policy announced by the government last year. And so under the pandemic of COVID-19, and there was a big concern about job loss and creating new jobs. And so Korean government announced the Green New Deal. And under the Green New Deal, we have specific policy designed for the mobility sector as well. And so the aim is to transition to electric vehicles and hydrogen vehicles. And many Korean companies are challenged by the task to build the ecosystem, and the policy outlines the details that are very much related to this area. To also talk about other government policies, and I'm sharing a timeline with you today. And regarding the UAM, so I'm talking about the urban air mobility, which is actually receiving a lot of attention lately. And so the test stage, UAM commercialization would be 2025. And so in respect to level 4 autonomous vehicle commercialization, the aim is 2027. Of course, Hyundai Motors are saying earlier, for example, 2024. But if you talk about the infrastructure as well as regulation on the government side, our target for L4AV commercialization is 2027. And then the UAM full-fledged commercialization to take place in 2030. And in respect to the future cars, in May 2020, there was a presidential the Korean president participated in a conference which dealt with the future car industry development strategy. And in June of 2021, there was the first AV transportation and logistics basic plan established. So last year, we had the basic plan for AV approved, and every 5 years the related act would be revised, and we will have various projects that will be sponsored by the government with a budget of $1 billion. And so there are various projects that are currently underway. In respect to urban air mobility, a lot of plans are being announced. So in respect to future car and UAM, we also have the preemptive regulatory roadmap. And so we want to make sure that the government is ahead of the game to be able to come up with the relevant regulation before the actual commercialization time frame. And so we also anticipate that the relevant basic plans would be announced. And for the mobility service, we have carpools and large size taxis related mobility services. And there were the incumbent taxi operators as well as the new mobility service providers. And there was a lot of contention happening in society. And so the government announced the Platform Mobility Innovation Vision 2030 in May of last year. Now I will take some time to talk about the some major Korean mobility companies and what projects and business models that they are working on today, and I also take part in this endeavor as well. So this is a landscape of the global mobility industry, and mobility is taking various forms. And for example, what was impressive about the Future Mobility Report published by the UK government is that it's very vast, and so from personalization to urban air mobility, they actually introduced a very broad range. But as you know, our global mobility industry is going through various changes. We have Google, and so we also have the 4 major OEMs participating, and we have BMW and Daimler also no longer participating in the autonomous vehicle cooperation, but they're still partners in respect to providing various urban mobility services. And so we also see a lot of M&As taking place. So for example, Honda is also investing to attain L4 technology, and for Amazon they acquired Zoox, and so it's really focusing on AV for the mobility of the logistics. And they also acquired Dispatch to promote robot delivery services as well. And when it comes to, for example, Japan, Nissan and other OEMs in Japan are cooperating very heavily in this area as well. And so this is the blueprint that I'm actually anticipating. So if we look at 2015, 2017, this was really OEMs, and they were looking at AI and mobility as a service and radar and AV startups, and they made a lot of investment in this area. From 2017 to 2019 until present, in respect to autonomous driving, they're focusing also in EVs as well. So we have the existing OEMs, but we also see participation or coalition of major companies. And of course, the progress has somewhat been stopped as a result of COVID-19. However, we believe that these activities will pick up as well. And in respect to Korea and Hyundai Motor Group, and they own both the Hyundai brand and the Kia brand as well. And for Hyundai and Kia, there's also the Aptiv, which was spun off from Delphi. And so they're talking about the cooperation with Aptiv, and they created Motional to do level 5 autonomous driving development as well, and that next year they're targeting the rollout of such L4 cars. And of course, the tier 1 suppliers such as Hyundai Mobis are actively participating in the ecosystem. And another thing that Hyundai is very key on is the purpose-built vehicles as well. So on the skateboard, we're not just changing the cabin, but it's really creating a ultra durable cars and special purpose order-based creation and the design of the cars. And so that's what they talk about when they're talking about the purpose-built car. And Kia is actually putting a lot of emphasis in this area, which is testified by their investment in Arrival. And so we also have Autopia, and this is for tele operations and also participating with Russia's Andex. And we also see that cooperation with with UK is in the UAM, urban air mobility. Well, we also have a lot of Korean startups that Hyundai is investing in, but for future car and CAVs, they are very keen in developing this technology. And for EV, they also have a standalone platform, a dedicated platform developed, and they will continue to build their EV business from this platform. Another major company in Korea to talk about is LG Group. Now, they have been a leader in the electronics area, but they're going through a major transformation to also include mobility business as well. And so they started to do AV and navigation, but now they also do car infotainment, autonomous vehicle, vehicle software, delivery robots, and future mobility. And not only this, but we also see that EV charging solution is also an area that they're focusing on as well. So for mobility as a service, Kakao Mobility has invested more than 100 billion Korean won. They're the leader in the mobility services. And recently, LG Electronics acquired JKW for the lighting. And so they were able to make inroads in this area. And most recently in 2021, for the e-powertrain area, there was a JV, LG Magna e-powertrain. Another notable company under the LG umbrella is LG CNS. And so LG CNS is looking at smart cities, notably Sejong and Busan. And LG CNS is playing a critical role in the development and the building of the smart city as well. And so they cover AI, big data, blockchain, cloud, smart transportation, robo-service, IoT, and smart logistics. So they have a breadth of technology for the smart city, and they also incorporate the mobility aspect in the smart city as well. And so they're very much putting all their focus into this area. And also, one of the key T-Money, so this is a settlement company, T-Money, and LG CNS is the second largest shareholder. So clearly, we have already seen their keen interest in the mobility as well. Now, LG U Plus is a telecommunications company. So they have 5G technology as well as industrial IoT, AI-based smart solution, and autonomous vehicle. And also, they are doing a lot of collaboration with LG Electronics and LG CNS. And of course, we also have LG Display in car and car mobility display. And for LG Innotek, they cover EV, connected car, AV electronics part, AV sensing, and communication solution. And last but not least, we have LG Energy Solutions. So they are the manufacturers of EV batteries and making serious investments in this area. And also for the auto lineup personal market that is currently developing very fast. And so we're talking about the battery swapping system and also battery as a service business model as well. And so as we look at the B2C market growing, and with the outbreak of COVID-19, there was a great focus on logistics as well as net zero. And so for the motorcycles, there was a need for us to transition to environmental friendly electronic auto motorcycles as well. So for LG, they have the manufacturing and system development. LG Energy Solution is capable of doing that as well. Another company that I closely look at is SK Telecom and T-Map Mobility. And so T-Map Mobility is a spun-off from SK Telecom. They had previously been a T-Map navigation service division of the Korea's telco. And when it comes to navigation services, it has it is the largest in Korea with the most number of subscribers. And they also had T-Map Taxi, and they established UT, joint venture with Uber, and their T-Map Mobility is spinning off this business as well. And so the taxi will fully be spun off and incorporate into the Uber business. And for the LBS business, they want to focus more in this area. And so for Kakao Mobility, I think that you will see a similar business portfolio. One of the key things they had focused on is the huge investment in the middle mile startup IRP in Korea. And for SoCar, they are one of the key investors, and SoCar is Korea's largest car sharing company, and the second player is called Green Car. And when it comes to SoCar, and there was also a mobility service provider called Tada, and there was a government related issue with Tada, and they were talking about the legality of Tada's mobility service. They were providing a large vehicle mobility service, but they were inevitably had to stop operations. And so they're only providing taxi service today, but they have VCNC, and that was sold to TOS. And for the mobility terrain in Korea, it's becoming wider and wider, and a lot of focus had been put into the mobility service. But TOS, as you know, is a fintech company. So for the mobility service providers, they have a lot of business with fintech companies. And so as they actually continue to grow bigger, they also need to make sure that they also have the payment capabilities. So we see fintech companies also taking a great interest in the mobility area. So I think that's one of the notable change that we are witnessing in Korea. Also for SK, they also have the rental car services. And one of the unique things about Korea is that we have a very long-term rental. So it's actually leased on an annual basis. And so for SK, very busy in this area. And we also have SK, they own a lot of gas stations, but in light of the greater penetration of EVs, they're also focusing on creating charging infrastructure, and the sites that they owned are actually transforming into multiplexes as well. And so most recently, with the advent of EVs, we have also the UAMs as well. So we also need to talk about spatial innovation as well. And one of the key companies that are leading the way is the Korea's SK Telecom and SK Group. Next, I want to talk about Kakao Mobility. A lot of countries are providing mobility services, and one of the things that is a big concern is monopolization. And for ride-hailing service is also something that we're very familiar with. And for Kakao Mobility, 93% of the users are actually subscribers of Kakao Mobility. And so in the case of Kakao Mobility, they have the Tago solution, and they acquired this company, and they also own 9,000 taxi vehicles as well. And if we look at the mobility as a service, we have Uber and Lyft, and we also have a lot of autonomous vehicle operators trying to enter the market as well. But Kakao Mobility is very interested in actually building alliances. So they are also working with Mars for AV, but then they're expanding into parking. So they have Parking Square and MyValet. So they have a lot of areas, but they also have cooperation with LG and Google and TPG. The Carlyle Group have invested in Kakao Mobility. This is a snapshot of Kakao's app. And so taxi is a regular average taxi, black is a luxury taxi, and for bike it's the electric bicycle. And then we also have designated driver, quick service deliveries, as well as airplane, interbus, my car, which also train, shuttle, carpool. So they cover various segments under the mobility industry. And we can also raise the issue where in terms of monopolization and the terrain of the mobility sector, how it's going to further develop. We also have a company called Humex, and they were the largest set-top box manufacturer in the world. And they also have a lot of automobile electronics specialties as well. And Humex have exited from their core businesses and really focusing in the mobility areas as well. So they acquired Chevy, which is a EV charging company, and also working with Chevy for the mobility service. And they also focus very heavily on the parking side as well. So they acquired High Parking, and through the acquisition, they were able to become an operator that process about 50% of the parking services in Korea. And they also have car rental services, as well as in cooperation with LG CNS, Smart City Consortium as well. And they also have a subsidiary called LTCAS. And most recently with Luno Samsung, they also have the other businesses as well. So they're going to B2C, B2B, and we're talking about the mobility transformation. And we see that they have a very aggressive drive into this new area. Up to now, I was able to go through some major companies that are doing mobility services, and they were really large corporates. But we also have many SMEs participating in this area as well. So you can see that a lot of these names are investing in the mobility area. And so we have these segments. So on the top, you have the ride sharing. So we have Papa, Silent Taxi, as well as Lane 4. But of course, grassroots domestic companies, they do have some limitations in growth. But we also have large incumbents, so Kakao, Tada, Uber, as well as UT and Cornatus. And this category is really the leaders in terms of the taxi hailing service. And for Korea, UberX is banned. And so in terms of the mobility service, this is the regulation is currently set geared to the taxi service. In terms of car sharing, we have SoCar, Green Car, and People Car. And of course, these two companies are dominant players in the market, SoCar and Green Car, but we also have other small players as well. Rent-a-car business, we have Lotte and SK, two big market leaders in this area. And of course, in the US, in the world today, and we also see a lot of car OEMs introducing subscription services. And so Hyundai and Kia are expanding their subscription offerings, and we also have Thrive providing subscription services for imported cars. And we also have Karo, as well as other companies. And for Korea, we have a lot of after-school education services, and they're also playing a part in here. In the area of personal mobility, and for Korea's personal mobility market, it's quite big. So I think that if you look at the US or the UK, the world was very surprised to know that the UK's e-scooter service, the sharing service, was a big issue at the time. And there are a lot of concerns as well as environmental issues as well. And for the UK, they actually put a lot of investment into making sure that there is a environmental friendly development and amidst COVID-19. And so we also have e-scooters, and we have about 60,000 units in service today. And we have Beam and also Bud and Lime participating in this area. And so for Korea, we don't have a ceiling or quota. And so this is also a developing market in the mobility area. If we move to the autonomous vehicle area, you see the names like Hyundai and also companies that Hyundai has invested, for example, 42 Dot. So Naver's former CTO is the founder of 42 Dot. And so they actually are the tier 0.5 in respect to the supplier hierarchy. And they can also play a critical role in providing the services that, for example, Hyundai needs. But we also have like Plus, Naver, Rightflux, Naver, and Automos as some leading companies as well. And of course, we also have to think about the regulatory issues. And for UK, I think that you have dedicated roads where for example, there's always a discussion about whether it should be on the pedestrian side or on the road side. And so I think that we will see limited implementation taking place, and there's some trial projects in terms of the delivery robots. And so we see companies like Ubility and Dilly. And for the parking providers, as well as the EV charging companies, we see a lot of names popping up in the marketplace as well. And so with greater penetration of EVs, there's also going to be even more alliances and market realignment taking place. For the delivery side, we have Burung as well as Barogo and other companies in this area. And we see a lot of startups in this area. We see not only Korean startups, but because Korea's regulation in the delivery area is well developed, because I've already previously mentioned the relevant basic plan and law, we see that foreign companies, foreign startups are also entering the Korean market because the regulatory framework is currently in place. And we see many Korean companies also trying to enter the foreign markets, but their activities have slowed down as a result of the pandemic. This is the Guidehouse Insight, and so we have this data from Navigant Research, and we're looking at the autonomous vehicle leaderboard. And so we see that Aptiv Hyundai is ranked in the 6th place. So we have the connected car and the autonomous vehicles. And for the autonomous vehicles level, so if you look at China, Japan, EU, and US, for the Korean OEMs, they are seeking international collaboration and cooperation, but they're not really at the forefront. If you I'm sure you'd appreciate that we do have Korean startups, and of course we also have major players entering the market, and they find niche areas, and some small companies are not getting the government funding that they used to because large players have now entered the sphere. But we see that AI, big data, and cloud computing, big data, mobile communication, blockchain, all coming together with the automotive industry as well. And for Korea, we're very strong in terms of the telecommunication as well as IoT. So I think this is a good area that Korea could collaborate with its foreign counterparties. Another things that I believe that we can actually seek further is that UK is very strong in science and in innovation, and we always benchmark UK in the area of science and innovation. And based on my experience, and when I have done international cooperation previously, we see that there's already good collaboration taking place between Korea's MSIT, MOTI, and MOHW with its respective counterparts of the UK. Now, when it comes to personal mobility and also UAM, there will be a lot of things that we need to do to get to social acceptance, and also regulatory framework development and how we approach the public is something that I think the two countries could cooperate. And of course, UAM, AV, and MAS, these are really areas that our two countries can participate. I already mentioned the strength of the Korean startups in respective areas in the previous slide, but because of COVID, their activities have slowed down. But I think that for the UK-Korea cooperation, we can also find an opportunity to bring Korean startups and their technologies to cooperate with their counterparts in the UK. Thank you.
네네.
예, 좋은 발표를 해주신
Thank you, Dr. Cha, for the wonderful presentation. And we had two speakers in the UK who couldn't take questions this morning. But while you are here, Dr. Cha is here, so I think we can collect some questions from the chat box. My question to you first is that we have so many companies, and it was really helpful for us to see large companies versus mid-size, as well as small companies, even startups. And what I felt was that when we're talking about the mobility service, and you talked about the Kakao Mobility and the platform business, but also you also have content service providers who put their contents on top of the platform. And it's not just Metabus, but it's really a real car, so hardware, and you need parts, components, and there will be also stakeholders in this area as well. So I think that there are so many different components to this, but we still have not reached a topping point. We saw a lot of activities, but then the growth is quite stagnant, and with so many companies in the ecosystem, will they all survive? As I mentioned previously, I think we have to have a phased approach. And so the global market, for example, is responding differently to Korea's time frame. And so 2017 to 2019, Uber, Google, Tesla really were at the forefront of the mobility services. Now, these three companies gave a big impact, and then the global OEMs moved, and then the startups followed. And so that was really 2015, 2017. There was a lot of investment into startups and a lot of M&A activities. So a lot of investment, and of course the market really wasn't formed just yet. And so that's why we saw a lot of alliances being forged. But now we see that EV market has come to age, and in 2025 that's going to be a big milestone. Now, the battery cost will go down, and we'll see that there will be clearly winners and losers seen in 2025. Another thing that we also have to look at is the CAVs. And so we're not just talking about a few companies and few functions, because we also have to talk about the contents companies and also VR and metaverse, and a lot of these future investment required to fully deploy CAVs. And now, of course, we're talking about ride-sharing services that are just over the break-even point and making profits. And so for us, we talk about the unit economy, and they actually need to calculate how they're going to turn a profit. And there's a lot of components that go into that calculation. And when it comes to sensors, we have sensor companies. They need to collaborate with OEMs, and I think that that's going to be a fiercely competed market. Thank you. Yes, thank you. Do we have any questions from the floor or from the online audience? We do have a few people present. And if you don't have any question, I'll just have one last question. So this conference, we look at technology, but we also want to identify areas of Korea-UK cooperation in the mobility area. And it was very helpful for us to see the strength of our respective countries. And can you further elaborate on this? I've worked with many companies around the world, and for me, unfortunately, I haven't actually experienced working with a UK institution or company. I think that when we're talking about future mobility, there is a policy report issued by the UK government. I think it was published 2 years ago, and for UK, they have a Road Transportation Act, and it was established a long time ago. But with AV and UAM emerging, what was interesting, for example, for e-scooters, it may look like a simple device, but when it comes to saving the environmental issue, the personal use is not allowed, and in terms of the sharing service, it was also blocked. But then because of COVID-19, by region, they are opening up. And so I think what's happening is that there is a dramatic change taking place within UK to provide various mobility services, including AV. And we also look at their keen interest in net zero as well. And so we see technological development, and we know that we have to have a lot of players in the market, but we also have to talk about safety issue. We also have to address the environmental issue, and we have to address the social acceptance issue. And what I really see is that UK is really doing a great job in coordinating all of these interests that are currently requiring our attention. And so I think Korea would benefit by collaborating with UK in these areas. So in terms of interacting with society, as well as promoting technological development, I think Korea could benefit a lot, and Korea can share its experience as well.
마침 한국자동차공학
Fortunately, in terms of the KSAE's mobile platforms, Dr. Hwang, he wants to raise a question. So you need to use a microphone for the broadcast.
예, 저 오래 기다리게 하셨으니까 좋은 질문 하셔야 돼요.
Please, I'm waiting to hear your question. Yeah, thank you for your presentation. So during your presentation, you mentioned TOS. And you were talking about the convergence of mobility and fintech. And for me, that wasn't something that I thought that was happening right now. So can you elaborate? Let me talk about two things. The first thing is looking at from the OEM perspective. For example, we have Hyundai, Kia, and OEMs. They're very keen on doing the in-car payment. And so the car will be a payment device. As you use your smartphones to do mobile payment, so there could be various drive-thrus, and the car could be a payment device. Or if you actually use infotainment services, there will be prepaid function also embedded in the car. So who will drive this? Would it be a third party, or would it be the OEM? Would it be a credit card service provider, or would it be a fintech company? So there's a lot of things that are happening beneath the surface, and overall, you have to understand the users' patterns. When they gas, how they gas, when they park, how they park. So you need to understand the vehicle users' behavioral data to do monetization in the end. And so as you accumulate data and set up the DV and do the necessary analytics, then you will be able to come up with the right business model. So for Hyundai, they also have Hyundai Pay as well as Genesis Pay. So they are already currently doing payment services. And for the service aspect, TOS processed 162 trillion worth of transactions. So this is a huge market, and which pay service or which credit card you use will be very critical. So you need to have data to understand what percentage are using Easy Pay versus credit card, and what is the transaction fees that are being imposed. And so all of these things are not only confined to taxis, because for me, I'm not too positive, but we also need to make sure that there is a seamless connection from the origin to destination. So we need to have the full OD data to understand the trips. So were there transfers, how many stops, and what sort of revenue sharing scheme will be introduced based on the different usage patterns of the people. And so I think fintech companies are looking into this now.
이상으로 세
Thank you very much. With this, we will end the third presentation. In the first presentation, we heard from David Wong from SMMT, and we heard his perspective. And we now heard from CEO Cha's perspective, and there were some differences. I think that was an interesting point. We will now go on to the last presentation of session 1. David Wong mentioned in the first presentation that autonomous driving cannot be possible just with sensors. We need connective infrastructure to support AVs. And as you know, Korea is a stronghold in communication technology, including 5G, and we are looking at cellular VTX and wave-based communication infrastructure, and there's competition of these two communication systems. And from 2015 on, we are seeing regulation on including communication modems onto vehicles. In 2030, we expect that to have a stable cellular network that will be used for AV and transportation. But this is quite complex, so we need to look at the Korean context to see how this technology will unfold. And we will be hearing from Director Won Sung-chun, the head of the Connected Convergence R&D Center at KA Technology Institute. And the title of his presentation is V2X Strategy for Future Mobility. And as was mentioned, Dr. Chung is the head of the Connected Convergence R&D Center at KAT and he has worked on various communication related activities in the automotive sector. And I'm sure we can draw a lot of insight from Dr. Chung's presentation.
백신 접종
And on a personal note, he is suffering from some complications after being vaccinated. And thank you very much for coming today, despite not being perfectly well. But in any case, thank you very much for giving me this opportunity to deliver this presentation. And I want to thank Professor Hong in particular for inviting me. And today I'm going to be speaking about V2X strategy for future mobility. The order of my presentation will be V2X overview, policies around the world, industry strategy, and so forth. First of all, connected car will have to connect with a wireless network to provide connection wherever you are and at any time. And through this connection, various services will be provided, and that is the purpose of the connected car. As you can see here, there are many systems and components that support this. And I'm going to be speaking about IVI and V2X, which is probably most important in the connected car. V2X and IVR, there are two aspects of V2X. It secures the safety of the driver and passengers. That's most important. So there is a public characteristics of V2X. That is why this is led by governments and policies around the world. For IVI, on the other hand, it is to provide convenience to passengers and drivers. So for this side, it doesn't have to be government-led. OEMs, platform providers, automakers around the world are developing these systems. V2X, as you can see, enables communication between vehicles and communication with network, communication with pedestrians, and communication with infrastructure. It's connected to everything. It is an IoT for vehicles, simply put. These systems have to be connected with the CITS, next generation transportation systems. They are going to be connected with these ITSs. And when there's forward collision risks or an emergency situation, you will receive warnings. And automated parking and also other services such as traffic flow control will be provided. So some trends of connected cars. On future cars, convenience and safety, it's being led by IVI and V2X technology. And on the connectivity side, to support this, we need large-scale data supply and low latency. So high speed, low latency communication is necessary, and this is being supported through 5G. And V2X is utilizing such cellular networks, and this is becoming a standard around the world. And as you can see here, connectivity is a term used to describe future mobility. And in 2020, already in many new cars, connectivity is being applied. In 2030, we expect that 100% of new cars will be applied with connectivity features. So we can experience both the current auto market and the future auto market through connectivity. So this is a keyword. As of 2020, globally, connected car market is already 100 billion USD. In 2030, it is expected to surpass 800 billion. So robust growth of connected cars is expected. So I would like to emphasize that it is an important part. And in V2X is important pillar. So until level 2, it's partial automation supporting the driver. And until this step, you don't need a lot of data. So there wasn't a huge need for V2X. But as we go to full automation, full autonomous driving, the vehicle needs to acquire massive data, and sensors cannot provide such massive data. You need to have an awareness and identification of overall transportation and traffic information. Therefore, there has to be communication with CITS to enable such level 4 autonomous driving. And here you will see the emergency situations that will provide warnings. And DSRC can provide such warnings. But afterwards, the data that is detected by the vehicle, including video and images, when this data is transmitted, DSRC will not be enough. We need to use LTE, cellular methods to support V2X. And when you go on to full AVs, it's not just partial AV. So you need to have overall transportation and traffic flow information, and it has to be integrated and provided in an organic way. Therefore, there will be massive data, and multiple connection is required. For this, 5G and beyond technology is a must. So to mention IVI system briefly, as I said, IVI is led more by the industry compared to the government. That's a type of platform being developed. As you know, Google and Apple have developed connectivity platforms exclusively for vehicles, and media streaming platforms and vehicle maintenance, automatic maintenance systems can be provided, and in-car payment system, so car pay systems are supported through IVI. As was mentioned, V2X has a more of a public aspect and characteristic to it, so it is influenced greatly by government policy. And looking at government policies around the world, in Europe, they have Euro NCAP 2025 roadmap, and according to this, they will establish laws and regulations by 2024, and it was announced that it's going to be implemented and executed in 2025. The specifications initially was DSRC, and that was the scenario that was made initially. But now they have decided that DSRC alone will not be selected. They will see the trend in the market, and cellular methods will be added on to DSRC. That's what is being contemplated by Euro NCAP at the moment. Next, in North America, and at NHTSA, they announced FMVSS 150. And in FMVSS 150, they stated that DSRC will be mandatory for V2X, and it was going according to plan. But then last year, 2020 October, FCC stated that DSRC is not enough to transmit massive data. That has become clear, and DSRC methodology has led to lower usage. Therefore, they decided to transit to a cellular-based V2X. And in 3 years, DSRC method will be withdrawn. So the North American market will go toward a cellular network-based V2S, and this is going to have an impact around the world. Next, US, what is in FMVSS 150, SAE J2945. So this is a scenario V2X driving scenario performance specifications. So this is a dynamic scenario. It's not stationary. It's various scenarios of dynamic vehicles communicating with one another. It's included in this specification. It started off with the DSRC. However, cellular network, even if it uses such networks, the message transmitting methodology itself will follow DSRC. And also in China, they were one of the first to decide on the cellular method standard. So they were the first to do so. And now the global trend is moving toward cellular networks being used for V2X. So they have led this, and they have even prepared a vehicle level test, and it's going to become a mandatory law, and they have to test vehicle level on the real road to see the integration, but this will lead to a lot of environmental issues. So for the real road situation, they will be using in an indoor environment, but it will be a real vehicle test. Similarly, Korea is also developing various technologies and standards on V2X. We have CITS being connected with the V2X, and we are one of the countries that are establishing CITS. And we have 15 scenarios for CITS, and this has been announced, and we have announced that the government will be supporting these 15 scenarios. So we have leadership here, but MOLIT is leading this, and MOLIT is influenced greatly by trends in the United States. So our specifications and standards were pretty much based on DSRC, but the global trend is shifting toward cellular networks. So just in July, Ministry of Science and Technology and MOLIT had a discussion and stated that by 2024, cellular method and DSRC will be pursued in parallel, and then in 2024, the superior system will be selected ultimately. So right now we have a parallel system, but in 2024, a single system will be selected. The roadmap that you see now, it's the communication technology roadmap for vehicles. So in addition to V2X, IVI utilizing cellular telecommunication is included here. And so there's WAVE using DSRC, and there is the 3G, 4G cellular communication. And the technology for these three systems, they have been completed and they're in mass production. For 5G, it is in release 16, so the standards are just being finalized, and the mass production will be entered into in 2024. On V2X technology, there was a cellular method competing fiercely with WAVE, and the advantages and disadvantages are clear of the two methods: low latency, and we can use Wi-Fi for free. In the same way, Wi-Fi had a big advantage that it was free to use. So that was DSRC's advantage. However, there's unstructured data such as images, and it requires large-scale data sending and receiving transmission. So there are limitations there. And WAVE method and LTE-based cellular V2X, excluding those differences, in terms of the specifications, there's not a lot of a difference. That's why there was so much controversy. But as we go forward with the 5G V2X based on the release 16 specifications, once this comes out, as was mentioned, the DSRC and cellular method, the advantages of the two is the 5G. So probably 5G will become the standard as we go forward.
현재 말씀드리는 5G VTX를
And if you take a look at now 5G V2X, you will see that it provides wide bandwidth, enabling massive data flow, and a lot of data can be accessed simultaneously. So it has multiple advantages. So complete autonomous driving and connected vehicles that will use video. And in order to transmit such video, 5G cellular technology will be the standard for V2X. And so this is something that can be expected. And this is the roadmap according to IEEE. They and 3GPP, they are talking about the cellular chips being used. The chips have already been mass produced, and it's on the brink of being applied in vehicles. And once the government policies have been set up, then these chips will be supplied. And 5G V2X, it's just in the process of standardization. Therefore, we don't have a communication chip that is in mass production yet. So the communication chips that we use in our cell phones are different from the ones that will be used in vehicles. And so the protocol and specifications have not come out yet. Through Release 16, we are now just getting the 5G communication chips for vehicles. And it will probably be 2024 when these chips enter into mass production. And once they go into mass production, we will get related components and parts. So now you are looking at the major global industry trends around the world. For the OEMs, GM was the first in the world to provide a OnStar, which is a connected car platform. And following this, Mercedes-Benz and Tesla are following very closely behind GM. And there's Google, which is a non-OEM, a platform company. Amazon, Apple, Google, MS are some of the platform providers that are trying to provide platforms, and they are competing fiercely with the OEMs. We do not see dominance yet, but one side probably will gain the dominance in this area. In Korea, we see that HMC and KMC, as soon as he became chairman of Hyundai Motor Group, stated that starting from next year, they will change all of their new car releases to be connected vehicles. And according to that plan, he has set up a technical roadmap for 4G, 5G connected system, and the components and systems have already been developed, and they are being applied to vehicles, new cars. And for 5G, as I stated, it's being developed, and from 2025, it's probably going to be applied from then on. And Hyundai Kia Motor Group, they are cooperating and partnering with platform companies to secure platform technology. Then, now let's take a look at the core technologies related to V2X. The first one that we can point out will be the communication module, including the chipsets. DSRC, 4G, and 5G will probably be used in parallel, and to have a smooth connection with them, for each of these communication systems, you need to have support, and it's probably going to be provided through a packaged communication module chip. PC5, there's the direct method, and there's also new interfaces to support network, uplink and downlink functions. So such chipsets are currently being developed, and Another one is you need to communicate with the outside environment, but in addition to that, you need to communicate with the various solutions and programs within the vehicle. So you need to connect with the various resources in the vehicle using a hypervisor multi-OS system. So that is also being developed. Next, on the device level, in addition to the chipsets, you need to have a hybrid communication device to support 4G, 5G, and DSRC. That's the communication system that is being used at the moment. So you cannot just select one of the communication systems. You need to enable communication with all of these communication networks, and therefore you need to have this common communication module, and you have to be able to communicate anywhere and anytime. So they utilize 4 antennas, and each of these antennas need to be used effectively. Therefore, you need to have a integrated and combined antenna system to minimize interference of frequencies and increase efficiency. Such devices are being developed. Next, you need to have software to operate the devices. And in software, the term stack is used because the communication has different stacks, and there are different programs that need to be used, and such programs have to be stacked up onto one software program. That's why we call it a software stack. DSRC and cellular systems, they use different chipsets. Therefore, in the physical level, the protocol and the standards, they're completely different. Therefore, the softwares supporting such physical systems are different too. But on the top layer, on the top stack of communication, SAJ has been decided will be used. So they will probably use the same messaging system, so the upper layer is expected to be the same. And a big difference from the past is that connected cars are connected to the outside world, and compared to stationary vehicles, it's very vulnerable to cyber attacks. And let's say a vehicle is on the road driving, and if there is a V2X security attack, it might lead to driving obstruction or driving location being exposed, or there can be illegal control of that vehicle, which may lead to large-scale accidents, safety accidents that's not comparable to previous cyber attacks. And in order to prevent such cyber attacks, we need to have protection systems that are different from the standalone systems. So each of the components have to have their own security protection, and there has to be in-vehicle related security protection, and there has to be security for V2X, and there has to be security for the back end, the infrastructure too. In addition to that, this all has to be put into a solution to provide protection and security against attacks of all of these systems. And SCMS and IEEE are some organizations that are setting up the standards for such cyber attacks. So I talked about the V2X devices. Next, on the V2X communication, for such communication, SAJ 2735, you have to have BSM, and this is mandatory. And through this, you can provide warning to the driver for various emergency situations, and there can be some control provided. And for this, if V2X is put into a vehicle, just by testing against VTX, it will not be enough. You need to test for the entire vehicle to validate the vehicle safety. That is why each country is requiring V2X vehicle level tests, and the test protocols are being developed. NHTSA in the United States has set up a standard for SAE 2945 to check for the security level and V2X. Components that go into vehicles and the components when they are being developed, it takes about 8 years or up to 5 years to be put into a vehicle, because it has a lot of components that go in that are put into a vehicle. You have to be careful about the interference of those components with other components, interaction, and so forth. So there's a lot of validation and evaluation that you need to undergo for a component to be installed into a vehicle. And when you do a real vehicle, real road test, it's not always the same. So it's not easy to repeat those tests, and it's not easy to compare standards. Therefore, the method that we are proposing is having a test chamber to provide a environment that simulates the traffic lights and traffic situation. And as you can see here, this method is already put in as a proposal for a standard into ISO. And once this standard is adopted, then this system will be adopted by OEMs to test their systems. And with this, I will end my presentation. Thank you very much. So we heard a very highly technical and in-depth presentation. Thank you very much, Dr. Jung. So Korea was the first to commercialize 5G communication, and 5G's representative use case was AV. But it was not realized for quite a long time, and some might have been wondering why it was not being adopted. Just because 5G communication is established, it doesn't necessarily mean that it will be applied in vehicles immediately. We learned through this presentation. How long will it take then for 5G to be applied in vehicles? It'll take about 2 to 3 years. It'll go into mass production in 2025 for 5G. And then after that, the technology has to be stabilized, which will need 7 to 8 more years. So for full connectivity, developing services and content and software based on such full connectivity, we will want to know when the market is going to be established. So would it be safe to think that the market will be set up in 2026? Hyundai Motor Company and Tier 1, 2 suppliers are preparing, but the chipsets have not been developed yet. The specifications, the standards have not come out yet. So they have completed the development to expedite the technology adoption. But so first of all, we need to have the chipsets, but for us to have a market being established, it'll be after 2025. The reason why I'm asking you this question is because traditional auto component suppliers, they need to realize net zero, and they need to develop EV components for their survival. They're being asked to transform themselves for survival, and for mobility, they are developing services under the assumption that AVs will be coming out. And that's fine for large companies with deep pockets. But for the smaller companies, they have to know when the market will unfold because they have to wait for this market to develop and ripen. So the technologies individually have been developed in piecemeal, but it will we'll have that system set up in its totality in 2025, it seems. Thank you very much for the presentation.
우리
So we will now have a lunch break, and we will resume session 2 at 1:30. Thank you for listening. Thank you.
Good afternoon. We would like to now begin the afternoon session. We are here to talk about the future mobility taking place in Korea and UK, and this is the second conference jointly held, and we have invited companies to present on the research that they are currently working on. We'll be looking at emissions, CO2 reduction, EV, CAV, connected autonomous driving. This afternoon, we have 5 presentations, and each presentation will take about 30 minutes, and we aim to conclude by 4 o'clock. The first presentation is titled Using Cooperative Infrastructure to Assist Automated Vehicle Making, and the presenter is from TRL. The second presentation is titled Ultra Durable Electric Powertrains for the CAVs of the Future, Insight from the Rubicon Project. We have Cenex and Hexagon Manufacturing Intelligence presenting this presentation. And then the third presentation, Improve Hazard Detection through Training and Testing on D-Risk Edge Case Scenarios. We have a presenter from D-Risk. The fourth presentation is on Cab Market Quick Wins, Automated Pods to Automated Logistics. We have Connected Places Catapult presenting. And lastly, Project Endeavor, using simulation to evaluate AV ride-sharing services at scale. And this presentation will be made by Immense. The topics to be covered will be as you know, because UK is really early morning, these will be pre-recorded presentations. And so unfortunately, we'll not be able to take questions live. I know that you are joining us via YouTube, so you could leave your questions in the chat box and we'll pass those questions to the relevant speakers. And so as you listen to the presentation, if you have a question, please post your questions in the chat box. Now, without further ado, we'll begin the first presentation. The title is Using Cooperative Infrastructure to Assist Automated Vehicle Making. This will be presented by Oliver House. Oliver House is a senior technical consultant. And as you will hear from the presentation, he's from TRL. It used to be public, but it has been privatized. And currently, under TRL, there is Smart Mobility Living Lab, and Oliver House is a senior technical consultant for SMLL. Prior to working to TRL, Oliver House has previous experience in vehicle testing, vehicle emission certification, and manufacturing. And after joining SMLL, he played a key role in the design and build of the test facility. He also technically authored guidance documentation for safety case development of connected and automated vehicles. And he is very much involved in working on things related to smart mobility. So we'll listen to Oliver's presentation.
Today I'm going to be talking to you about how we're using cooperative infrastructure to assist automated vehicle decision making on public road trials in the Smart Mobility Living Lab. I will introduce you to TRL and the Smart Mobility Living Lab. I'll introduce you to Project Safe City. I'll describe the concept of cooperative infrastructure. I'll provide details on how we're using roadside infrastructure to assist connected and automated vehicles in on-road decision making. I'll give a quick personal introduction to myself. So as I mentioned, I'm Oliver Howes. I'm a senior technical consultant for TRL, and I work as part of the Smart Mobility Living Lab team. My previous experience has been around the internal combustion engine, from calibration development and emission testing, certification testing in different parts of the world, and also manufacturing of the internal combustion engine. But recently my focus has changed into new mobility and connected and automated mobility. So I played a key role in the technical design and build of the Smart Mobility Living Lab test facility in London, which launched in September 2020. Since the launch, I've run numerous technology projects utilising the SMLL facility to test and validate new mobility technology in the real-world environment. I've also developed a number of guidance documentation and processes for developing and assessing safety cases for automated vehicles. So a quick introduction to TRL and SMLL. TRL was established in 1933 within the British government as the UK's Transport Research Laboratory and was subsequently privatised in 1996. TRL is the parent company and has 6 main focus areas. So our focus areas are in environment and decarbonisation, transport safety, transport for sustainable development, digitisation of transport, automation in transport, and new mobility. So there's a real focus around transport around all these 6 themes. So I mentioned TRL being the parent company of 2 different sub-companies within that group. All companies have the clear vision of developing clean, efficient transport that is safe, reliable, and accessible for everyone. So that really drives the focus for all TRL businesses. Within the TRL business, we have TRL Software. TRL Software is an innovative software solution developer covering transport issues at all scales in the UK and internationally. They develop software products for asset management, for urban traffic control systems, to improve on road safety, and also to help with junction and signal design. The Smart Mobility Living Lab, which is the team that I work in, is a company within the TRL umbrella as well, and is an urban testbed environment created to accelerate the growth and deployment of new mobility solutions. It's located in London in the UK, in one of Europe's largest cities. A little bit more about the Smart Mobility Living Lab. So as I mentioned, it's located in East London, and it's the world's most advanced urban testbed to accelerate the creation of new mobility solutions. We have 3 different focus areas within the SMLL, or Smart Mobility Living Lab. We have test, where we support customers test their new technologies in a real-world environment. We have simulation, where we support customers testing their technology in a simulated environment before deployment in the real world. We also have an innovation community, where 30 plus like-minded organisations come together across multiple sectors to bring their minds to focus on the challenges of new mobility as we move forward. The SMLL facility is located in 2 locations in East London. One in Stratford, which is the 2012 Olympic site, and one in the Royal Borough of Greenwich. We have 24 kilometres of monitored road network between those 2 sites. This is a little bit of a close-up on those 2 sites, Stratford and the Royal Borough of Greenwich. Stratford is a much newer environment. It's got a lot more new infrastructure in there as it was developed for the 2012 Olympic Games, and it offers generally lower complexities for different types of new mobility technology. On the flip side, the Royal Borough of Greenwich is very feature-rich. It has very complex environments for new mobility due to the slightly older landscape of the environment. Across the 2 test areas, we had a range of different road types, from dual carriageway to residential roads, busy high streets, and sections of roads up to 50 miles an hour and down to 5 miles an hour. Each of these little icons, the colourful icons, represent one of our monitoring sites, our main monitoring sites around the monitored test site. Each of these main monitoring sites will have a series of mesh columns and mesh monitoring sites coming out of these to give us a broad coverage of the whole test area. We have 2 offices, one located in Stratford and one located in the Royal Borough of Greenwich, and these are notated by the star on the maps. So what have we deployed out on the roadside? This image on the left-hand side here shows you a typical installation of our sensors and our infrastructure out on the roadside. So throughout the whole test facility, we have over 300 CCTV cameras to capture movements on the road network. We have over 40 V2X roadside units to be able to communicate with connected vehicles on the road network. We have 200 plus Wi-Fi mesh units to be able to communicate this roadside generated data back to our central data center, and also a 20 kilometers of private fiber network to enhance this communication back to our central data center. We also have a high amount of compute at the edge and also in our central data centers as well. So what does this enable clients to do? This enables clients to acquire data from SMLL sensors to enrich the data generated by their own technology and their own sensors. Our modular platform allows clients to integrate their hardware and software within the SMLL stack. Our V2X and connectivity platform allows connected trials to be taking place in a public road environment. The 20 kilometers of private fiber network allows the testing of fiber for such things as above ground event detection. And we're also here to support the planning, the development and the deployment of real world trials. As an independent facility, we also offer independent analysis and performance reports on technology trials which are taking place within the SMLL facility. We can benchmark customer equipment and customer technology to a range of sensors and equipment we have within the SMLL facility to provide a ground truth and a comparison to that data set. As well as our real-world testing environment, we also have a simulation capability. We have a digital twin of the whole monitored section of the SMLL road network, so all 24 kilometers. And this allows us to explore various different simulation activities, one of which we've looked into recently is simulating the movement of different road users around the road network and start to simulate some edge case scenarios in particular focus areas. Now I'll give you a quick introduction to Project Surf City and what we're doing with the cooperative infrastructure trials. The Project Surf City. Project Surf City is it exists to create a blueprint for how autonomous vehicles can become an everyday experience for everyone. It's here to inform policymakers and budget holders on how they can plan for future transport infrastructure and services that are safe, intuitive and highly efficient. There are 3 main focus areas for the project, one of which is technology, developing cutting-edge technology to overcome the complexities of automated driving in a busy city. There's people, how we create a user experience that puts people at the centre of consideration. And also scalability, working out how these services can be deployed at scale within the UK. There are 6 different project partners within this consortium project. We have Nissan, Hitachi, Connected Places Catapult, TRL, University of Nottingham and SBD. This project is sponsored by the UK Government Centre for Connected and Autonomous Vehicles and also industry partners. A large part of the work we're doing within Project Surf City is running a number of real-world public trials with connected and autonomous vehicles utilising the information sent from the cooperative infrastructure. Cooperative infrastructure has a broad range of use cases, and currently national highways are utilising roadside sensors to detect stopped objects on the motorway network within the UK and transmitting this to a central data centre. Operators within this data center are then able to close certain lanes of the motorway network to create a safer environment for those stopped vehicles, whether they're broken down or they've had an incident there. Future use cases for connected and automated vehicles is vast. It could be in the form of helping vehicles with route planning. It could be enhancing onboard decision making. It could allow the offboarding of vehicle compute requirements to mean there's less capability requirements on board the vehicle. It could expand the automated vehicle operational design domain in hazardous areas if they can rely on information shared to them by roadside sensors. And it can also start to read static and dynamic hazards on a road network and share those with connected vehicles. These different use cases are all going to require different types of requirements. Main requirements currently being explored are latency and data accuracy. As your latency and data accuracy improve, you can start exploring a different number of use cases. For example, when you've got a poor latency and poor data accuracy, you can still use this information for high-level route planning. As your data accuracy improves, you can then start exploring how you can use this information for lane-level detail for route planning, and also start predicting vehicle trajectory estimations. As you start improving the latency of this system, so from object detection using roadside sensors to digestion of information on the vehicle, you can start looking about how onboard sensors and onboard compute can be substituted for the roadside technology. There are a couple of different use cases we're exploring within Project Serve City. Illustrated here on the slide, on the left-hand side, we've got a use case where we're using roadside sensors to be detecting objects and hazards on the road network, which we can communicate to a connected vehicle. This puts less reliance on the sensors on board the vehicle itself, and it gives the vehicle an enhanced view of the world, where hazards might be located around a blind corner. The second use case, which is what illustrated on the right-hand slide, is where we're using roadside sensors to detect whether the path is clear for a connected and autonomous vehicle to transmit through. So the example here is where we've got a series of static vehicles parked on the roadside, and our connected and automated vehicle needs to move around these to proceed. This roadside sensor is detecting whether this pathway is clear and sends a message to the connected vehicle, allowing it to move around these parked vehicles safely. So how are we doing this? What technology have we got to facilitate this type of testing? So as I mentioned previously, we have over 300 monitoring sites around the SML facility, and within these we have CCTV cameras which can capture scenario data and hazards and objects on the road network. This captured data will be transmitted to cabinets located on the roadside, where this sensor data will be processed at the edge. This processed data will then be packaged up into V2X message formats following ETSI standards, and then transmitted to local radios for local broadcasting. When the messages have transmitted to a local radio, these are then broadcast to connected vehicles in the area following the ETSI standards again. Connected vehicles on the road network are then able to receive these messages, and they can use these to influence the decision making of the connected and autonomous vehicle. This is a little illustration of the equipment we're using as well. So on the left-hand side here, we have a digital example of the equipment. And in the middle image, we have a photograph of what the typical installation looks like within the SML facility on the road network. This right-hand image illustrates the roadside cabinets we have. We have 35 of these roadside cabinets strategically placed around the 24 kilometres of road network, which act as local hubs to be managing the network and also providing a level of edge compute for processing the roadside data. Here's a short video of how we're using the roadside sensor data and processing this for detecting objects on the road network and understanding static and dynamic objects. So as you can see here, the edge compute is processing the camera data to detect dynamic and static objects in this environment. We're also segregating the road network into 3 different lanes, which allows you to understand the movement and trajectories of different types of vehicles. This data can then be packaged up into V2X message formats and transmitted to connected vehicles in the road network to give them an enhanced view of the world. One example of this is displayed here. This is a particular scenario within the SMR facility where multi-lane dual carriageway are travelling in both directions. There's a bus stand around this blind left-hand corner, and vehicles often travel around this left-hand corner in the left-hand lane and get stuck behind this parked bus with other cars passing on the right-hand side, not allowing them to get past. What we're exploring here is using our roadside sensors to detect the location of this bus and creating of a denim message. This denim message will then be broadcast to vehicles approaching this bus stand, informing them of the location of the bus and allowing the connected and automated vehicle to adjust their path planning to accommodate this bus. For example, they might be moving from the left-hand lane into the right-hand lane to avoid congestion behind the bus and improve efficiency of their movement throughout the road network. Within the Project Surf City, we're also exploring different ways of communicating to connected vehicles and different architecture platforms for this. The main one I've spoken about so far is using DSRC, or Dedicated Short Range Communication Radios, to transmit to connected vehicles. This is where V2X messages broadcast from local radios mounted on the roadside will broadcast messages for connected vehicles to receive, and has an approximate range of 1 kilometre. Another method we're looking at is where information is shared from a central third-party server over a cellular network to vehicles. In this concept, connected vehicles will subscribe to data over the cellular network from the central data platform. A slight alternative to the second option is where information from the third-party server is shared to the vehicle operator's own servers over an internet link. This information is therefore able to be subscribed to by the operator's connected vehicles on the road network and can be managed accordingly. As well as using this object detection and classification data for generating V2X messaging, we're also using it to understand edge case scenarios on the road network and visualizing these in a virtual environment. These 2 videos here demonstrate how we simulated a real-world scenario in the virtual world. So thank you very much for your time. And if you have any questions, please feel free to contact me. My name and email address are provided on this slide. Thank you very much.
예, 올리버.
Thank you very much, Oliver House, for the presentation. We heard about autonomous driving based on infrastructure and how traffic congestion can be improved. And I think this is something that we have been working on in Korea too. And while listening to the project, I felt that it's not an area in which Korean companies are working with the UK. And here in Korea, we are carrying out projects similar to this, that it's being emphasized and focused on in Korea. So these are some projects that the UK and Korea can work together and collaborate to reduce errors and trials and expedite and fast forward the realization of these technologies. While listening to the projects, I felt that this deals with the relationship of AVs and other vehicles and issues related to AVs with this technology and vehicles without these technologies, and devices that are supported with these functions and features and those that are not. And so this is quite of a complex issue. So it's not something that can be solved by individual companies or individual countries. So I hope that Korean companies, research centers, academia can do work jointly with the UK companies and UK industry. I would like to thank Oliver House for the presentation. We will go on to the second presentation of this session, and it is titled Ultra Durable Electric Powertrains for the CAVs of the Future, and insights from the Rubicon project. We have two speakers for this presentation. One speaker is from Cenex, and the other presenter is from Hexagon Manufacturing Intelligence. CAV, as we have connected AVs, the powertrains and related components have to be designed in a reliable way, and that's what the presentation is going to be about, and we will be hearing from two companies on this topic. We will hear from Cenex first. Victor Lejona from Cenex will provide the first part of the presentation, and Victor has a mechanical engineering background and is a technical specialist at Cenex. His role focuses on the development of software tools to assess the economic and environmental performance of low-emission vehicles. So he works on developing tools to help improve performance of low-emission vehicles. And it will be applied in vehicles. And in the process of applying it in vehicles, he also leads the monitoring and data analysis of vehicle trials to evaluate the feasibility of such technology. So we'll hear the first presentation provided by Cenex, and then we're going to be hearing from Henry Tanner, Principal Engineer at Hexagon Manufacturing Intelligence. Henry is a Principal Engineer for R&D projects at Hexagon Manufacturing Intelligence, and he's going to be speaking about drive lines and powertrains. We'll go on to the second presentation.
Hello, and welcome to this presentation, which will try to answer the question, how will autonomous mobility affect the future powertrain? My name is Victor Lejona. I'm a technical specialist at Cenex, and today I'm presenting alongside Henry Tanner from Romax Technology. We're presenting the findings from Project Rubicon, which obviously stands for Ultra Durable Electric Powertrain. The project's objective is to design a powertrain for autonomous vehicles that can withstand very high utilization at lifetimes of over 1 million miles. And the hypothesis that we are trying to test are that personal transport will be provided as a service by small autonomous battery electric vehicles. And we think that the combination of not having a driver and having high distances and high utilization can provide a very interesting business and environmental case, and that it will be a viable model that can compete with other more conventional urban modes of transport. The research question that this project is trying to answer are alongside main three pillars. One is, will the vehicle work? So we're assuming that autonomous vehicles will work, but will the vehicle be able to run for 1 million miles? Well, that's the type of questions that Henry will be trying to answer later on. At Cenex, we focus mainly on whether this will be a commercially viable concept in terms of revenues versus costs, payback periods, etc., and whether the concept is environmentally friendly, so taking into account the whole life cycle of the vehicle all the way from the manufacturing process through the use phase to its end of life. The team of this Innovate UK funded project is Romax Technology, which is part of Hexagon. They've been focused on durability assessment, component design, and software development. MPEL have been providing support and specialist advice on the design of the powertrain, mainly around motor and inverter. And then here at Cenex, we've been focusing on, as I said, on the business case modeling, the environmental case modeling, and then also looking at the operational demand that these vehicles can have in the future. Let's set the boundary conditions first. We are focusing on future CAF archetypes. So we're looking at what OEMs have been hinting as their future concept vehicles. And we look at these pictures and we mainly can classify all of these vehicles in two main archetypes. Your small two-seater urban pod, around 450 kilos, small batteries, or your larger 4 to 6 passenger carrying vehicle, obviously 3 times as heavy and with obviously larger batteries as well. But for the purpose of this study, we're focusing mainly on the small pods. Also setting some geographical boundaries and some technological boundaries to this. So we're focusing mainly on level 4 CAFs. So level 5 CAFs, as you probably know, are fully autonomous vehicles and they can operate under any condition. Level 4 CAFs, however, have an operational design domain, which is the range of conditions where these vehicles can operate. And it's not just geographical, it's also weather conditions and road infrastructure, availability, terrain, etc. But we're focusing here on geographical boundaries. And we've looked at the current trials of level 4 CAFs. They are around 25 square kilometers typically, the areas where the vehicles are trialed. So we've picked a few areas around London where the vehicles will operate, and basically we'll be modeling how having a few vehicles in each of these areas will take place. Now we know the boundary conditions, let's focus on the modeling itself. So first of all, we developed a fleet utilization model, which has the objective of understanding how a specific fleet with certain vehicles of certain specifications can be deployed and how they will be utilized in a specific area of a city or in a city in general. And combining the modeling of transport demand and transport supply, we're able to know how that fleet is going to be utilized, when it's going to be charging or driving or parked, the kind of annual mileages it's going to be doing, etc., etc. Let's focus on the demand modeling first. So for demand modeling, we've mainly used Department for Transport statistics, publicly available statistics around number of trips per person per year, split by trip purpose, or split by trip vehicle as well, type of vehicle, whether it's taxi or private car trips, etc. So that way we're able to work out how many trips can be demanded per day in a certain area. This is just a single number, but to add some granularity to it, we have looked at road traffic statistics as well to have the different trip demand for different days of the week and different hours of the day. Let's take one step back and now zoom on the supply side of the model, where we need to know several things. We need to know our type of duty cycles, which we have developed ourselves from our Cenex database of drive cycles. We need to know typical distances of trips and what percentage of those trips or of that mileage is carried out with passengers as opposed to without passengers or looking for them. And then we need to know specifications about the vehicle, how it charges, battery capacity, and its efficiency. Combining all of these factors together, we are able to tell how many trips per hour each of those vehicles can provide. And then if we combine that with the outputs from the demand model, we're able to tell how many vehicles are going to be used for different days of the week and hours of the day in one of our London level 4 CAF areas that we defined before. Because the objective of this ultra-durable powertrain on this project is to have vehicles that are highly utilized, we're aiming to have a small, relatively small fleets that are going to be pretty much on demand during the whole day. So as you can see on the graph on the right, if you have a small fleet, the vehicles are going to be, either driving or charging most of the day, except during some nighttime hours where they will be parked because there's not enough demand. But however, still, this achieves a 90% utilization being defined as not parked, so either driving or charging. And you can see, these vehicles are doing 107,000 miles per year, which is a lot. And, they will reach 1 million miles, which is our powertrain life, in 9 years, which is roughly around the same amount of time that vehicles are owned by people in general these days. What happens if we have a much larger fleet, say a 4,000 vehicle fleet, where utilization drops a lot, so it's not quite what we want for our kind of ultra durable vehicle. Still 75,000 miles per year, pretty high, but as you can see, during the whole night and even sometimes during the day, the fleet is not fully utilized. Obviously, there are some limitations with this model because it doesn't provide all the granularity we want, for example, geographically or temporally. So we are trying to, we're currently carrying out some more sophisticated geospatial modeling, where we want to model a range of different scenarios with the objective of answering the question, for the environmental and business cases to work, how does the future need to look like? So these scenarios are going to include things like, charge point locations, whether we prefer to charge at public or depot charging, shifting the charging to nighttime, because as you've seen from the graph before, it would be definitely smarter to charge at nighttime when the demand is low. Enable or disabling trip sharing amongst strangers that are sharing perhaps a similar destination or have a similar origin of the trip, trying out different vehicle types, trying out different fleet sizes, etc. So we're currently modeling this, and we'll present the results of this at the end of the project at the beginning of 2022. Now let's focus on the business case. So we're gonna see first how the cost and the revenue breaks down. So first, so we're comparing human-driven taxis with normal durability cabs with ultra-durable cabs. We're looking first just at the vehicle costs, the electricity costs and the charge point costs. But then what happens if you add overheads or the tax for revenue? Well, those costs are not that big, as you can see in these graphs, because even if you have a cab fleet where you don't need drivers, you still have to clean the vehicles, charge the vehicles, you still need non-driving staff. You need a booking system for the trips, like an app. You need to rent land, an office. You need marketing to promote your business, etc., etc. But what you can see from there is, if you take everything into account, the vehicle costs, the overheads, etc., and also the revenue from the taxi first, the vehicles, the human-driven taxis are not have a negative business case, as opposed to the cabs, which have a positive business case. And this graph shows the results for 10 years, over a period of 10 years. The reason why the human-driven taxis are showing a negative business case is that we're using a taxi fares of 98 pence per mile as a prediction of the future taxi fares in London. The prediction for future human-driven taxi fares is 2.13 pounds per mile, which is quite far off that number, and therefore that's why the human-driven taxis are making a loss in this case. Let's focus now on the cabs themselves. Look at how their costs evolve over 10 years. So you've got the normal cab, normal durability cab on the left, and the ultra durable cab on the right. So you can see that you need a lot of powertrain replacements on the normal cab. You need 5 of them over 10 years. as opposed to just one on the ultra durable CAF. So even though the ultra durable powertrain adds 11% to the vehicle capital costs, over 10 years, you get a vehicle cost saving of around 6%. However, we haven't modeled the battery or ultra durable battery in our project because it was out of scope, but it's definitely an opportunity for further research because you can see that both vehicles need a lot of battery replacements. As you can see, it's the little dark blue bars in there, so they need about 6 battery replacements, both vehicles over the lifetime. If we look at the whole fleet in terms of a whole fleet investment case, what we see is using the same figures as before. The human-driven taxi fleet is making a loss, as we saw, and the CAFs are making a gain using the 98 pence per mile taxi fare. However, we play around with different trip fares, and we said, well, what would happen if we want to have a 3 to 5 year payback? Well, the human-driven taxi needs a fare which is round about 2.15 pounds per mile, which is around a prediction of future taxi fares. However, the CAFs are around 70, 80, 90 pence per mile, which is quite similar actually to the current kind of medium car total cost of ownership in pence per mile for the average UK drive cycle and ownership, which is obviously quite encouraging to see that these vehicles could compete with private car trips, this being a mobility as a service offering that could compete with those type of private car trips. Finally, we have the business case sensitivity. This chart shows in the axis what happens when all of those variables have their central value. So we identified 10 variables that we thought could have an impact, and then we changed them one at a time from a low to a high value while keeping the rest of the variables in their medium value. So just to isolate the effect of each of those variables. What we can see in there is trip fare is very important, and if there's competitiveness between different fleets in the future, that could cause profits to decrease quite a lot. Driving ratio with passenger is very important, so it's therefore key to optimize the algorithms for pickup and drop-offs of passengers in the future. Non-driving staff salary, quite important as well, and you'll still need to pay staff obviously in a CAF fleet. And then the charging power has quite a significant impact too. Even if you are dealing with small batteries here for a small vehicle, if you're not charging fast enough, you're losing time that you could potentially be out there, driving around passengers or looking for them. This is the end of my presentation. Thank you very much. And now Henry will talk to you a bit more about the engineering case and the design and durability case for this type of vehicles. Thank you. And just a very quick note before I hand over to Henry. So I appreciate this is a lot to take in just 15 minutes. So you can download this white paper that we just released with all the detailed insight into the modeling and the results from Project Rubicon. And just also please watch out for the LCA environmental impact that we are carrying out, and also the detailed geospatial transport modeling that we're doing with our friends from IMEMS, who I believe are also presenting in this conference. So please watch out for that as well in the few coming months. Thank you very much, and bye-bye.
Hello. Thanks, Victor. Fingers crossed our presentations have been seamlessly merged by someone in marketing. So I'm Henry Tanner. I'm a principal engineer at Romex Technology, which is now part of Hexagon's Manufacturing Intelligence division. And so at Romex, we're really mechanical engineers, and we do a lot of electric transmission design, and we also have our own software tools that are used in the design, development and simulation of electric powertrains globally. In the automotive industry is our main sector, but also we do lots in wind and marine and rail and aerospace. Essentially most industries that have gears and shafts and bearings we are quite active in. So I put this project together, and that's really because in a lot of conversations we've had internally about autonomous vehicles, one of the questions that haven't really been answered or addressed in publicly at least is what effect does autonomy have on the mechanical design of an electric powertrain. So we hear a lot about the sensors that go on to a vehicle to make it autonomous, and you hear a lot about the software that makes it autonomous and the new business models that they enable, which is kind of what Cenex has been looking at. But in this project, we wanted to look at the consequences on the mechanical systems that still underpin autonomous vehicles, basically. So we tried to bound this problem a little bit, and we're really focusing on autonomous taxi fleets. And one sort of clarifying, unifying question we had was how do we design the best vehicle for an autonomous taxi fleet? So that was one of our key questions. And by this, we sort of firstly have to define what we meant by the best. And so in this project, we looked at the best vehicle would be the one that's cheapest to operate or has the highest operational profit and also has the lowest environmental impact. And you'll see that these two metrics actually you can cover a lot of engineering details go into evaluating these two metrics. So the first thing we did was we wanted to have a look at the state of the art. We wanted to really see how normal passenger cars that exist today would fare on these two metrics. And this sort of makes sense because a lot of the conversations around autonomy at the moment is basically getting normal passenger cars and just putting sensors on them and replacing the driver with some AI, and really keeping everything about the car the same, but adding sensors and replacing the physical driver with a virtual driver. So what we did was, if we just considered the status quo, which is let's assume that the future is just going to be keeping normal vehicles as they are, but retrofitting them with autonomous equipment. What's going to happen? So we had a look at some benchmark data, and there's a recent study called Carbon Counter, which was done by MIT in the US, and they basically look at a few hundred modern vehicles, and they score them on two metrics. So if you look at the axes here, you've got the costs of a vehicle along the x-axis, and you've got the greenhouse emissions on the y-axis. And what's interesting about these metrics are, take the costs for example, that is the total life cycle costs of including purchasing the vehicle, the fuel if it's an internal combustion engine, or the cost of the electricity if it's an EV or a hybrid, plug-in hybrid, and also takes into account the maintenance costs. And then what it does is it looks at the average lives of what these vehicles actually do in operation, and by life we mean distance travelled in this situation, in this context. And then it gives you a cost per kilometre, so a number of dollars per kilometre for all of these vehicles. So that's the x-axis. You've got the Jaguar I-Pace there. So the Jaguar I-Pace across its whole life will cost you roughly 0.375 pence, sorry, $0.375 per kilometre to operate that in the US. on the y-axis, you've got greenhouse gas emissions, and what's interesting here is it's not just the greenhouse gas emissions at the tailpipe. It's the greenhouse gas emissions across the life cycle of the vehicle, including the production cost, the production carbon, manufacturing all of the steel, the magnesium, the plastics, the lithium-ion batteries, the electric machines, the power electronics. All in, how much greenhouse gases are emitted in its production and its lifetime. So for combustion engines, this also includes the tailpipe emissions. For battery electric vehicles, this also includes the emissions that it requires to create electricity for the grid as well. And you can select different grid carbon intensities for different countries in the carbon counter study as well. So this gives you a really good picture about how cars perform, and you can see here there's some horizontal lines that show you the emissions targets for different cars on the road. So at the bottom you've got the 2050 emissions target, and if you can imagine all of the cars on the road become battery electric today, we're still a huge distance off our 2050 targets. In fact, if every single car became a battery electric vehicle today, we'd be far off our 2040 targets, and we're predicted to be nowhere near that. So all of these yellow dots, these battery electric vehicles, are still quite far off our emissions targets, so we've got a long way to go, which is a bit of a problem, really. So this project became a lot about how do we design a vehicle from the ground up that is extremely cheap to run and extremely non-carbon intensive to produce. So yeah, it's how do you get one of those dots into the bottom left-hand corner. So we had some different optimization strategies. First one was we had to establish a baseline. So for this we had a generic 5-seater C-Class electric vehicle. So that's kind of like one of the best yellow dots in the previous graph. So we're sort of starting off with the kind of the best state of the art and seeing how we can improve it. So that will be our generic C-Class EV, and the first thing and sort of the main thing we've been doing for this project is looking at ultra durability. So this is extending the life of the vehicle relative to the production carbon and the life cycle carbon. So it's got two huge benefits. One is it makes it cheaper to run because you're not throwing a vehicle away every 200,000 kilometers or 300,000 kilometers, and the embedded carbon stays in there, and you don't have to remanufacture new vehicles so often, which is the sort of main contribution to battery electric vehicles still being so damaging to the environment. So we've done lots of work on ultra durability, and I'll mention that briefly. We also looked at vehicle right sizing, so actually looking at the economics and the use cases of autonomous taxi services, and thinking, do we actually need 5 seats? Do we need this big C-Class vehicle? Can we shrink that down a lot? So having a fleet of autonomous taxis with a range of sizes became a very important idea to reduce the costs and the carbon emissions. So actually 2-seater vehicles could be a much better way to go in the future, and also of course improved efficiency is a major factor, reducing the costs and reducing the carbon of vehicles, which is no surprise. Finally, we look at a combination of all three. So, an ultra durable, ultra efficient, small vehicle would massively improve our autonomous taxi fleet for these two metrics. So that's the kind of idea. And we'll look at this in a little bit more detail. The durability became the main aspect of the project. So there's how do we optimize for it? Well, firstly, doing an architecture trade-off study. This is basically looking at a huge number of different vehicle concepts, powertrain concepts in particular. Basically, there's a huge number of options you've got when you design a car, in what motor you choose, what electric motor, how you lay out your system, how you connect different parts of it to other parts of the system. So doing very early concept studies is an important way to optimize for durability early doors. So we've done a lot of that. So number two is a systems approach required. So really, to properly optimize durability, you have to understand how the different electric vehicle subsystems interact, and oftentimes automotive players are quite siloed in different departments. So the motor person is not really connected to the inverter designer or the transmission designer or the battery designer. So a systems understanding and having simulations that let you do sort of virtual test rigging of a full powertrain together is really the best way to optimize durability. Real-world driving data, we use this to understand the real loading conditions that an actual vehicle would see on the road, particularly an autonomous vehicle, and we've leveraged Cenex's sort of vast databases of real-world driving data, which is great because we don't have any of that, and that's really helped us in the project in our simulations. And finally, we developed the Rubicon team at Hexagon developed a example sort of virtual model of a vehicle. So we kind of have designed a test vehicle virtually just for this project. You can see it here. And this really allows us to play games and run a huge number of simulations and optimization studies to make a really ultra durable powertrain and drive system. So there we go at the top there. This is kind of showing you the systems approach that we've taken. So really coupling together all of those vehicle subsystems and co-simulating them together, we found is the most important thing you can really do to understand durability on a systems level. Okay, so some examples of this then. So having this model is really important to us because it means we can look at quite damaging simulations. For example, a car driving over a pothole, hitting a curb, hitting some ice, and having one wheel skidding whilst one wheel is stationary. Sharp increases in acceleration and deacceleration. These are all a subset of the simulations we've been able to run on part of this project, and really have a look at the sort of damage that is incurred from these events as the sort of shocks propagate through the whole of the driveline. And this is something that isn't really done out there in industry in any particular depth, because it's very hard to build these models and it's very hard to get different departments linked up together. So yeah, we've basically got this full vehicle model, and we've got this virtual environment that we can drive it over stuff, hit it into things, and our feedback from the market is that for most customers, they've sort of got this feeling that this is actually, these types of events are the events that kill durability, and these are the events that are quite poorly understood. So we've done a huge amount of work into looking at these damaging events and assessing all the drivetrain components from these types of events, basically. And then from this, we then run optimizations. So every single component in this model is parametrically defined. So we run it through different simulation scenarios, and then we run component optimizations to increase their durability. And our findings are basically that, yes, you have to increase the cost of your components to increase the durability. But with a model like this, you can increase the cost in a very sort of intelligent and cost-effective way. So you're adding material only in the places where you need to, and you can leave material off other parts of the system that aren't being fatigued. So yeah, it's a live project. It's still ongoing. We haven't published all the results of these analyses yet, and it's only a 15-minute presentation I've got for you. So you do have to wait for a slightly longer presentation to see the detailed results, but this just gives you a flavour of what we're working on and what we're working towards. So thank you very much. Appreciate the invite to this conference, and any questions, email me or ask me.
예, 울트라
Yes, you have heard from two speakers on the ultra durable electric powertrain, and to be able to develop a PowerPoint system that could last for about 10 years to also have a range of 1 million miles. And so there was also discussion about electrification and also equipment replacement and various other costs. And we had also an example cited. So to what extent, what level of durability that's required. And so in terms of electrification and automation, if the driver isn't there, then we want to put the car to use so that we could monetize the business. And I think that's the right approach. But on one hand, and this is a Korean English conference, and where are you going? I wanted to ask you a question. I will save my question for a later time. And so for the UK, the black cap is its signature of UK. And so in terms of designing the service and in also assessing the reliability, how feasible is it to really think about an unmanned taxi service? The reason why I posed this question is because in talking about the business model, in terms of the maintenance, the risk, in terms of the weather conditions, and also these unexpected events, all of those things can happen, but can we all put those variables into a scenario and model, and will we be able to have developed a service stable enough to withstand all possibilities? And I think we also have to address the social responsibility and relationship issue as well. If the speakers were here, I have many questions to ask in terms of where we are, what further do we need to prepare for, and what sort of information could be shared so that we could prepare for the future better. Next. We just heard the ultra durable electric powertrains, and the next presentation is improved hazard detection through training and testing on D-risk edge case scenarios.
예, 알겠습니다. 예, 그거를 이제 들으려고 했습니다.
Now, unfortunately, we don't have the next clip available, so we'll just have to skip to the next presentation. The next presentation is related to the connected AV market, quick wins. And we're talking about the automated pods to automated logistics. And we have the speaker, Tom Webster, to present. And so he is a principal engineer of Connected Places Catapult. So if you're, please give me a sign to let me know that you're ready. So we'll hear the fourth presentation first, and then go back to the third presentation in the program. So please go ahead.
Tom Webster, a principal engineer at Connected Places Catapult, and I'm talking to you today about connected autonomous vehicle market quick wins. Firstly, a quick introduction to the Connected Places Catapult. We are the UK's innovation accelerator for cities, transport and places. There are 9 Catapult centres set up by Innovate UK, the United Kingdom's innovation agency. Connected Places Catapult came into existence relatively recently with the merger of the Transport Systems Catapult and the Future Cities Catapult. We are not-for-profit, neutral and independent. We exist to drive growth, spread prosperity, and to help decarbonise. We do this by bridging and connecting between businesses and public sectors to leading research and are looking to create new markets and opportunities. And this is a snapshot showing the projects that we have been involved in internationally. This slide takes a brief look back to UK history of innovation in the mobility sector. Back in the 1980s, the UK was at the forefront of computer-optimised traffic control, for example with Scoot, which provided optimised and adaptive control of signal networks based on real-time traffic flow data. In 2003, the large-scale rollout of Oyster Card revolutionised London's rail and bus public transport. In 2006, the UK was an early adopter of smart motorways, easing congestion with variable speed limits and road shoulder use. In 2015, Lux Pathfinder has the claim of being the world's first autonomous vehicle deployed in the public space. In 2019, London implemented the first large-scale 24-hour ultra-low emission zone. And in 2020, the CAM test bed was launched with the capability to safely take ideas from concept to development, both virtually and physically. For context, looking at the bigger picture of urban mobility as a whole. In March 2019, the Department for Transport published Future of Mobility Urban Strategy. This defines the government's vision and approach, underpinned by these 9 principles, defining what society needs both economically and also for quality of life. Following on from this, in August of this year, Innovate UK, supported by their partners including Connected Places Catapult, published a report called the UK Transport Vision 2050. This develops the vision further for the research and innovation context. Based on these 6 pathways, this provides a vision and roadmap for autonomy. However, it is also worth noting that automating travel overlaps with the other pathways, which is shown here. This is reflected in the business model pathway, which recognises that the rollout of technology and digitisation will provide opportunities that transform business models. With this being an international audience, I should firstly clarify that in the UK we tend to use the term CAV, meaning Connected Autonomous Vehicle, which I will be using throughout this presentation. This is largely the same meaning as the AV, Automated or Autonomous Vehicle term, used predominantly around the world. Connected Places Catapult has helped provide a rich collaboration space for CAVs in the UK. This includes these 12 projects, each of which involves several collaboration partners. In this presentation, I'll talk about some of these CAV projects, guided by the narrative of achieving quick market wins. There are many development stages involved in the rollout of future mobility. This is a particularly significant factor. As is often the case for mobility, when the operations are safety critical, as this needs a high level of validation and confidence to be achieved. We support this journey by being involved in all of these stages as part of our projects. This starts from understanding what society needs to shape strategic policies through developing concepts of operation and prototyping and implementation and refinement. We work to achieve this vibrant, intelligent and connected mobility space where technology satisfies the challenges of society. Now looking at the market opportunity for CAVs as a whole. In 2020, we worked with the UK Centre for Connected Autonomous Vehicles to produce a CAV forecast report. Shown here now are some of the headline figures from this report, highlighting the expected size of the global and UK CAV market in 2035. So this is estimating that the UK market will take about a 6.5% share of the global CAV market, and that CAV technologies take about 15% share of the overall CAV vehicle market. However, these numbers are a 2035 forecast, so let's look at some of the technologies we've been looking at in the more immediate term. For example, the Autonomous Valley Parking project that concluded in October 2020. This was delivered by a consortium of Parkopedia, providing car parking services, the Centre for Vision, Speech and Signal Processing at the University of Surrey, providing robotics and localization capabilities, and Connected Places Catapult with expertise on safety and operations delivery. The project delivered these 5 objectives. Firstly, to develop automotive indoor parking maps and markers that enable the autonomous vehicles to navigate a multi-storey car park. Secondly, to develop the algorithms that allow the vehicle to localize its position accurately using minimal camera, ultrasonic and inertial sensors. Thirdly, this was demonstrated in a variety of car parks to show and trial this self-parking technology. Fourth, the safety cases developed and prepared for in-car park trials. And fifth, we engaged with stakeholders to evaluate perceptions around this autonomous valet parking technology. This project generated the publications that you see on the right-hand side of the slide, and these can be downloaded from the project website. I do think there is value to be recognised in the contribution each deployment delivers to the wider CAV body of knowledge, especially when these learnings are shared publicly. This body of knowledge helps future developments overcome the barriers that they face. This image gives some sense as to how the system operated. We can see on the left-hand side the vehicle operating in the car park, and there are localization markers placed around the car park. The automated driving system's computer vision detected these markers to localize its precise position and navigate. As you can see on the right-hand side, there's an overlay of the identification. It does of course present an additional challenge when operating indoors, so that you have no line of sight of GNSS satellites. This next project, which is geared more towards consumer vehicles, is the Multi-Car Collision Avoidance, or MACA project, which concluded in March 2020. This trial involved the wireless communication between vehicles to enable them to cooperate with each other while avoiding obstacles. This was the first implementation of full-sized cars working cooperatively together under automated control. In doing so, core technologies were developed that will help to deliver more advanced and safer automated driving functions to be rolled out to future production vehicles. And on the project website, there's a video that can be seen of this working in action. This next project is the MK5G project that we've been working on this year as a project partner. This includes the implementation of a 5G cellular network that supports a cluster of commercially focused demonstrations of automotive mobility and hospitality logistics at the MK Stadium, which is the home of the MK Dons Football Club. The focus of Connected Places Catapult on this project is managing the operational design domain and defining the use case and outlining how 5G can be used to optimize AV services. There are many partners involved in this project, including Imperium Drive, who are providing teleoperation technology, and Origo, who are providing and operating the automated vehicles. Something else we've been involved in is CAV standards development. This included the development of the CAV standards strategy in 2017, the subsequent standards program, and the CAV standards roadmap in 2020. This is a snapshot of the 2020 CAV standards roadmap content, which is structured on 6 thematic areas. Even mapping the standards for CAVs is technical and complex, let alone the content of the standards themselves. However, the importance of standardization should not be underestimated, as they are vital for supporting productive relationships between developers, suppliers, regulators, and other stakeholders. This leads on to assurance, which is an important area for CAVs. CAV products can't be released to market without a system to authorize their use, and the public and authorities are of course highly concerned about safety and other factors. Last year we worked with the DFT and WMG to produce a comprehensive report for this, called the CertiCAV Assurance Paper. The goals for this were to develop thinking and assess options for safety assurance for highly automated vehicles and to demonstrate aspects of safety assurance in simulation. This slide is showing what is covered by CertiCAV at a very high level. Essentially, the assurance framework is providing a context and approach of how to release CAVs to market. The common assurance practice is putting together a common system of understanding for how organizations could explain and manage CAV systems between each other. Then there is best practice for CAV system development, so how a technology developer would undertake their processes to develop the system and validate and test it. And then a process for approving CAV systems undertaken by an independent body. So, for example, something we included and outlined in CertiCAV is what the organizational ecosystem involved in deploying a CAV looks like. CAV deployment on public roads cannot be achieved by the efforts of any single organization. So, for instance, this CAV here, it might be developed by one organization, one technology development. However, it may require a different organization to operate it. Additionally, there are regulators who need some understanding as to how the system is operating, traffic authorities, and many other organisations who are all involved in some shape or form in a deployment. So several organisations must build a common understanding and work together in order to support deployments. This is why a common practice is vitally important. The question of how safe is safe enough for automated driving is a common sticking point for CAVs. We put a lot of effort looking into how requirements for CAV can be described. Rather than attempting to define a single target, such as positive risk balance, we suggested a more nuanced, conditional approach, as this is a complex topic that involves not only safety, but the practicality and balancing of many factors, including following rules, cooperating with other road users, and keeping traffic flowing. We used a set of driving criteria developed from a previous music project as a base for defining what essentially should be achieved by good driving. We then developed a system for defining performance requirements, which involves a set of performance indicators that we developed. CertiCAV helped to feed into the UK authority activities. Looking at those, the development of the automated lane keeping system in UNECE has developed a body of knowledge in several areas. This is seen as significant in the UK, but also it's seen as being just the beginning of an ongoing process. This year, the DFT are running a major collaborative program to develop safety assurance and approval scheme for automated vehicles. This is focusing on the quick win, so to speak, of low-speed automated vehicles that operate at converting from miles per hour to kilometers per hour up to 32 kilometers per hour on roads with speed limits of up to 50 kilometers per hour. This will further develop the body of knowledge for CAV, feeding back into these areas and others. This then allows ongoing development to take place. Putting all of this together and how this relates to market opportunities is considered by the Drive for Automation report that we published in April. This focuses on Level 4 automated road transport and discusses how to navigate the steps of taking a product to market and their associated challenges. So, for example, to deliver a new mobility solution to market, you need to go through these 5 steps. And significant challenges must be overcome to complete each of these steps due to the scale and complexity of the problems faced by autonomous road transport. So there are significant and complex barriers to overcome in developing CAV capabilities, gaining assurance, developing trust, and building cooperation between stakeholders. However, the magnitude and nature of these challenges scale significantly based on the nature of the technology being developed, as shown in this diagram below. We describe this as being influenced by 3 factors. The first of these factors is the constraint of the deployment environment. What the CAV needs to perceive from its surroundings impacts the sensing and artificial intelligence capabilities that need to be developed. The second factor is the complexity of the driving behaviour. This influences the extent of manoeuvres and decisions made by the CAV, which in turn impacts the scale of defining and validating the CAV behaviour software. Something like justifying the interpretation of complex driving codes in a diverse set of situations is a huge development challenge and also raises complex ethical and regulatory issues. The third factor is the potential harm of operations or occupational risk. The operation of CAVs in public spaces is safety critical, and attributes such as operational speed strongly influence the consequence of failures. Where deaths are possible, the level of scrutiny needs to be high. These factors altogether impact on the capabilities that the developed technology needs to satisfy. So there's a relatively low challenge on this side of the chart, increasing up to a very high challenge when you have highly complex driving behavior, high risks, and unconstrained environments. So there are several barriers to overcome. However, overcoming these barriers may be enabled by the CAV ecosystem. This is the backbone of technology, know-how, governance and relationships that supports the development and delivery of CAVs. The robo-taxi type of CAV products that can handle more diverse environments and have higher driving capabilities are attractive in their economic potential and environmental impact. However, their route to impact must overcome significant barriers and must therefore be supported by a mature ecosystem that will take time to develop. The types of CAV that are more constrained in their use may have less market potential, but they can be brought to market earlier. And we need to recognize the key driving force that they can provide to growing the ecosystem by feeding back learning and development into the CAV ecosystem, which then helps enable the more mature, the longer term projects to be realized. So it is important to recognize the learning value and ensure that experience from CAV activities is captured to grow the CAV ecosystem and allow acceleration of the market for future more complex systems. We identified and considered 4 key categories of level 4 CAV opportunities. The first of these is controlled area driving, which is using CAVs in controlled private areas such as warehouse cargo transport and factory passenger transport. As these environments are well controlled, the development challenges are reduced substantially. We suggest that investing in common practice for these applications would increase the market base, accelerate further development, and help other types of CAV draw upon this experience to accelerate their development. The second type we outline here is the driving assistant. These are CAV driving functions that can take over from the human driver to perform a particular driving task in a specific environment, such as a parking valet or a motorway chauffeur. Development here is perhaps largely governed by large international vehicle manufacturers. They are, however, a significant part of the CAV ecosystem that shapes how other types of CAV are understood and assured. The third type is driving as a service. These are CAVs that provide a potentially confined but complete journey as a service and of passengers or goods, so including delivery robots, passenger pods, or even automated trams. These have significant potential to deliver environmental improvements by reducing carbon emissions through increased vehicle sharing and reduced emissions per mile. Delivering these would also grow the CAV ecosystem significantly and therefore enable longer-term opportunities with broader markets to be delivered to market. The fourth type is intelligent mobility. This is the delivery of CAVs capable of providing versatile end-to-end journeys, such as automated buses and autotaxi, otherwise known as robotaxi. Bringing these to market requires long-term development and investment. The CAV ecosystem must be grown to enable products to be brought to market. We suggest that this opportunity has the potential to significantly reshape the transport technology and manufacturing industries, and therefore how we live and travel in the longer term. There are benefits in strategizing long-term plans on which types of this opportunity support policies and to guide developments on this route, including medium-term stepping stone projects. So to summarize what we've covered under this Drive for Automation report, we believe it's important to recognize the different types of CAV due to the difference in their challenges of bringing them to market and the differences in their environmental and societal impacts. It's important to factor in the value of short and medium-term opportunities in that they grow the CAV ecosystem, and this then enables more complex CAVs with wider markets and wider impacts to be brought to market. Products within the controlled area driving and driving assist categories are typically closer to market release than the other categories due to having less challenges to overcome, but deliver fewer overall benefits. However, we should also consider the value that they bring in building the body of knowledge that helps bring other future opportunities to market. Driving as a service and intelligent mobility types bring the greatest economic, environmental and societal benefits. However, intelligent mobility products in particular require significant investment and are a much longer term prospect. Therefore, we should perhaps consider the opportunity of driving as a service products may provide to deliver to the mass market while delivering economic and societal benefits and continuing to build a shared body of knowledge that helps to enable intelligent mobility in other areas. So as an overall summary, my closing points are that to deliver CAVs to market, it needs to be recognised that stakeholders must build productive relationships and have common understanding with each other. Availability of CAV governance, assurance and standards will help provide certainty to the market, and this will enable ongoing investment and growth by removing current market uncertainty. So perhaps a key win of these quick win shorter term opportunities is by helping to generate and develop this body of knowledge, which allows the market to overcome challenges of the future and deliver bigger, longer term opportunities. Thank you everybody for your attention to my presentation, and this is my email address if you would like to contact me.
CAB market quick wins.
We heard about CAB quick wins, market quick wins. We heard from the principal engineer of Connected Places Catapult, Tom Webster. Through this presentation, we heard about autonomous parking and parking in an unmanned parking lot and multiple car collision avoidance. So how collisions can be avoided through the coordination of multiple cars. And we also heard about connectivity, including 5G, and how this will help in servicing AVs. We heard about various technical barriers and social network human factors, government regulation, and what needs to be agreed on. So we heard an in-depth discussion about these various factors through the presentation. AVs and connected AVs, it's clear that it's the upcoming technology. But in the process of this technology evolving in the next 20 to 30 years, we don't know exactly what the position will be, but there will be subset technologies that support the evolution of these technologies. So I'm sure that there are many areas in which we can collaborate with the other companies and the UK. We were not able to bring up the video for the next presentation, and that's why we changed the order, but we will go on to the third presentation, Improve Hazard Detection through Training and Testing on De-risk Edge Case Scenarios, and this presentation will be delivered by CEO of De-risk, Chess Stetson.
치스 맞겠죠 제가 체스는 그의 그
Chess completed his doctoral and postdoctoral work in computation and neural systems at Caltech, and previously earned an AB in physics from Harvard. He has 3 patents issued and 3 patents pending, and he works on providing AI machine learning solutions to Fortune 500 companies. And he also provides core knowledge graph IP. And he has provided such technology to financial service firms and autonomous vehicle companies. Next, we will be hearing from Chess Stetson, CEO of De-risk.
안녕하세요. Thank you so much for joining this talk, which is titled Improved Hazard Detection through Training and Testing on De-risk Edge Case Scenarios. And this is for the UK Korea CAM Conference 2021. My name is Rav Babra. I'm the Business Development Manager at De-risk. And today I'll be joined by Niels Goldbeck and Lorenzo Nicolini, 2 core De-risk team members.
My name is Niels Goldbeck, and I'm De-risk's lead engineer, responsible for the technology stack that allows us to collect, analyze, and simulate edge case scenarios for autonomous driving.
Hi, and I'm Lorenzo Nicolini. I'm an AI engineer at De-risk, and amongst other things, I've worked on using edge cases to retrain perception models.
Today, we're going to demonstrate a new set of tools for handling the complexity of autonomous vehicle edge cases, and show how they can be used to make AVs respond to high-risk events sooner and much more accurately, which has the potential to result in much safer and higher performance autonomous vehicles. We're going to start by reviewing the problem that AVs currently face, which is that they aren't actually driverless yet, and they'll need to handle orders of magnitude more in edge cases to get there. Then we'll go into the data sources and how to cluster them into a training manifold, some new tools for exploring the data and its embedding into the training manifold, and then we'll show how we can retrain on this manifold of edge cases using simulation. And finally, transfer to real-life data as we show the retrained network detects real-life high-risk events sooner and better. So, to review the problem, it is of course that autonomous vehicles still aren't driverless, and they need to be since getting the human out of the loop is what will ultimately make transportation much cheaper and safer. AVs, and the ADAS technology we expect will evolve into full self-driving cars, still exhibit a huge number of odd behaviors, phantom braking and wheel wobble, which are symptoms of false positives. Or worse, they get into terrible accidents because of false negatives, meaning they fail to recognize a hazard, even and sometimes especially when it's a hazard that a human would have no trouble recognizing and responding to with an evasive maneuver. The problem comes down to edge cases. As far back as the DARPA challenges, AVs have been developed first towards easy or center cases. For perception in particular, the most used data sets, like KITTI, include no collisions and few near misses, and don't differentiate low and high risks. So, from the perception stage onward, AVs are not built to recognize and contend with edge cases, because in many cases, the AV perceptions can't even see the high-risk event anywhere near enough time to respond to it. Edge cases are the high-risk scenarios and events which are individually unlikely, but together make up all of the risk. And if you think about it, training mostly on easy center cases is backwards. Even though high-risk edge cases are infrequent, they're the most important thing to pay attention to. And according to the classical definition of an edge case in a convex space, if AVs were trained on all the edge cases, you'd get the center cases for free. But how could we know what all the edge cases are? Well, we can start by focusing on collecting data from high-risk scenarios in order to map out the whole space. So we can collect data from a variety of sources, especially in and around major cities with the kind of tight, tricky interactions with pedestrians that AVs normally hate. And front-facing and dash-cam data, of course, both from public and private sources, and heterogeneous CCTV data from around the world. We can also employ formal failure mode analysis, which generates synthetic edge cases from engineering first principles. And finally, structured and unstructured text from accident reporting and insurance claims data, which makes sure we've accounted for all of the dangerous and expensive accidents for which there wasn't any video data. Now to Niels, who will describe our knowledge graph in more detail.
The edge cases that we obtain from different data sources are extremely diverse. So the eventual data repository needs to be one that respects the heterogeneity of the underlying edge case data. To make them useful for downstream retraining of artificial intelligence, they need to be organized into a taxonomy that supports a very high dimensionality. For this purpose, we have developed the DRISC knowledge graph solution. Think about all the different pieces of information that are required to describe an edge case scenario. The static environment, like the geometry of the drivable surface, traffic signs, and so on. The trajectories of dynamic objects, road user actions, like a cyclist signaling before turning, weather conditions and surface conditions, material properties like reflectances, and so on. All these properties of edge cases can be encoded in the DRISC knowledge graph. For example, consider an edge case where a spare tire falls off a truck and flies into the path of your vehicle. In order to simulate many variations of this edge case, we need to describe the tire's trajectory, its exact position and orientation over time. In some cases, we can obtain the trajectory directly from a data source, for example from a video recording. In other cases, we estimate the tire's size and mass and use a physical simulator to obtain realistic trajectories. This is also a good way to create new edge cases, for instance, one where the tire is larger and heavier than in the scenario recorded in the data. The more information we can estimate about the tire, the more interesting our edge cases get. If we estimate its angular momentum and elasticity, we can simulate how it would skip forward when it bounces towards your vehicle. And by modeling its diffuse and specular reflectivity in multiple wavebands, we can analyze how different sensors would be able to detect it. One of the advantages of our knowledge graph technology is the ability to encode sparse data. Not all scenarios have to be defined on the entire spectrum of potentially relevant properties. Instead, the scenarios are only connected to the components that are required to describe this specific edge case. And the scenario components are in turn recursively connected to relevant subcomponents, properties, and semantic annotations. Another advantage of the knowledge graph approach is the ability to visually and interactively explore this hugely complex edge case library. Here we demonstrate a new kind of user interface, which is advantaged by GPU acceleration and allows 100% graphical querying of every possible variation in the edge case data. It also embeds the data into manifolds, which are two-dimensional views of the edge cases. These manifolds allow us to identify clusters and gaps in the space of edge cases and estimate the extent to which a certain set of training or test data covers the space of risk. Here's an example of how the scenario data is directly encoded inside the knowledge graph. First, you see an image of the underlying detections in pixel space. And then the right is a sparse version that stores just the attributes necessary for encoding the entire scenario. It's these sparse features that can be used to classify the scenario in different ways. The manifold is an embedding of all the edge cases into a single structure, defined by a distance metric. Variations in the manifold are meaningful variations to those edge cases. sampling across the manifold then provides representative and independent scenarios for training, validation, and testing on edge cases. Here you can see a projection of this manifold in our interactive tool, where you can click on individual nodes to bring up simulations of these scenarios. Manifolds like this have the property that similar scenarios are close to each other and different scenarios are distant from each other, which is important for ensuring an evenly distributed sampling across the entire set of edge cases. With this method, we avoid overweighting any kind of scenario type, including, of course, center cases. I'll now hand over to Lorenzo to go over the process of using this manifold to train an object detection network.
So we'd now like to show you what happens when you train on data from this manifold. And each node in this manifold represents one scenario that has been simulated and processed to identify the most important hazard frames within it. Then a standard object detection model, such as Masco CNN, is retrained on the data sampled evenly across the manifold. And through the UI, you can visualize the performance across the whole space of risk in real time as training is occurring. So here the loss is shown on a red to blue axis, and you can see that by training using this tool, you can visualize the different regions of the manifold and see the neighborhood in which it's easy and difficult to retrain on. This can be done automatically, but note that this tool is also fully queryable and interactive. And what I mean by this is that the loss metrics are actually also stored in the graph alongside the data itself. So for a quick illustration of the power of this interactivity, imagine you've trained your network to uniformly have a low validation loss across the space apart from one node. The user can then take a look at that node and see how the data is and expand the data around that particular neighborhood in order to provide more and richer training data for further retraining. So stimuli like this of white noise, textured pedestrians, and background can be useful because even though they're not realistic, they can establish performance on scenarios that are representative of and connected to many other kinds of visual appearances. So we retrained our models completely on simulated data, but we still saw very strong transfer to real life. And specifically, we saw a performance increase, primarily on edge case scenarios, wherein the vehicle is confronted with high-risk events that will actually end up colliding with it. As you see, performance on non-risky, non-edge case scenarios is comparable to standard object detection performance. And it's only after retraining that performance on the high-risk events ends up becoming vastly improved. So to the left are annotated frames that come out of the KITTI train network, and to the right are frames that come from the network that we retrained, specifically optimized for edge cases, according to the process that we are describing through in this talk. So you can see that the affirmative detections of the vehicles end up appearing on the right much sooner than on the left, and successful detections appear over more frames in total. The aggregate results suggest that there is a 6-fold improvement in time to first detection and a 2-fold improvement in the total number of frames detected, but only on the vehicles that ultimately collide with the ego, therefore the high-risk vehicles. And in contrast, detections of vehicles that are not high risk, that did not end up hitting the vehicles, is on par with the KITTI, or the ones on the left, the KITTI network. Even though these results were achieved by training using only simulated data, the next steps will be for us to use real-life edge cases and to use simulated edge cases superimposed on this real-life data in order to get even more robust retraining.
Now, another use case of this same framework is, of course, real-time testing, or even retraining the entire stack with reinforcement learning. Here, you see a different projection of the manifold in the top left, and the dot represents the scenario that the AV is on right now. And the mainframe is our schematic representation of what's going on. And when the AV has a failure, as it just did, what you'll see is that the dot starts to hop around the local neighborhood and select scenarios that are nearby the failed scenario in the manifold. Then, when the traversal algorithm is satisfied that it's got enough data from that local neighborhood, it will again start jumping to the most distant scenario from the ones in the manifold that it has already visited. So using this kind of traversal algorithm, the AV can make sure that it's covering the entire space of risk scenarios in the shortest number of steps possible. So to summarize, to solve the problem of retraining autonomous vehicles to perform better on edge cases, a comprehensive repository of scenarios can be assembled from heterogeneous data like CCTVs, accident reports, failure mode analysis, and insurance claims. To cover the whole space of risk, we actually construct a manifold of edge cases. We can explore this manifold with a special tool that allows a knowledge graph to sort of meet an embedded projector. Then we can retrain on the manifold, and then we can improve the time to the earliest detection of a high-risk event.
Thank you so much for letting us share these results with you. Credit especially goes to members of the D-RISK team, including Lorenzo Nicolini, who conducted the retraining, Shona Curtis Walcott, Hugh Blaney, and Nils Goldblack, who all constructed the knowledge graph. And of course, to Kieran Jesadasan and Chess Stetson. Another thanks also goes to the D-RISK Project Consortium, which is made up of Claytex, DG Cities, and Imperial College London. Another thanks goes to the UK Centre for Connected and Autonomous Vehicles for funding D-RISK to construct the ultimate driver's test for self-driving cars. If you would like to learn more about our work, please reach out to me via email, rav@drisk.ai, or visit our website, drisk.ai. Gamsa Hayo.
detection.
So right now, you have just heard about the improved hazard detection through training and testing on D-RISK edge case scenario. Chess Stetson and his colleagues presented. So learning about possible events that could take place and preparing ahead of time and how to avoid hazards. And so that was the gist of the research. And in preparing for the AV era, I think this is a very important research. And I think that the deliverables from their work will also be very much helpful to the various research and development that many of us are currently undertaking. This takes us to the last presentation of the afternoon session, and the title is Project Endeavor, Using Simulation to Evaluate AV Ride-Sharing Services at Scale. And from Immense, we have David Williams, CPO, Chief Product Officer, to present. Dr. Dave Williams is a Solutions Director at Immense, and he has more than 15 years experience in the public and private sectors. And he has been working across highways, public transport, aviation, and environment. And currently at Immense, Dave leads the product and solutions team. And he is working with early-stage clients and collaborators to shape the future of their innovative simulation as a service platform. So without further ado, we will listen to Dave's presentation.
Hello, my name's Dave Williams and I'm the Chief Product Officer at Immense. I'm going to talk to you today about Project Endeavor. Immense are a software company from the UK. We were founded in 2016 with an aim to make simulation more accessible to decision making. Over the past 5 years, we've built a simulation platform to do just that. A big focus of ours is on accessibility, We want it to be easy to use and easy for you to apply simulation to the toughest decisions in transport and infrastructure. We've been involved in the Project Endeavour for the past 2 years alongside our consortium partners, and I'm going to talk to you about it today. Project Endeavour is a programme designed to accelerate and scale the adoption of autonomous vehicle services across the UK. It consisted of 4 separate trials of autonomous vehicles, in addition to user research, safety case development, and service simulation. Crucially, it's not just about the vehicle technology. As a multidisciplinary project, Endeavour has enjoyed a wide range of partners. Oxbotica are the consortium lead, providing AV software. DG Cities are an urban innovation consultancy conducting user research around preference and attitude to autonomous vehicles. Immense have been conducting and developing technology for city-scale service simulation, whilst TRL and BSI have been developing safety assurance. Finally, Oxfordshire County Council have provided a local authority perspective. We've been very fortunate to have been well supported by the UK government from both the Centre for Connected and Autonomous Vehicles and Innovate UK. An enormously important part of this programme has been trialling the autonomous vehicle technology. We've had 8 months of activities across 3 cities, including a public trial which catered for 225 passengers. This has added up to nearly 6,000 autonomous kilometres on public roads in mixed traffic, which is a fantastic achievement by the team. Today, I'm going to talk to you about how we've used simulation within Project Endeavour. We're past the point of developing technology without a market in mind. So whilst Endeavour has done a lot to develop technology and to do this in a safe and consistent way, we need to pay special attention to the commercial viability of the technology. In this case, how will it be deployed as a passenger service? If we're going to evaluate the operating model, we need to do this on a much larger scale than limited trials. And it's far better to do this in a simulated environment than in the real world. We're no stranger to simulation across transport, automotive, and infrastructure. And in the case of autonomous vehicles, we can't yet test everything that we want to in the real world. If we've learned anything over the past 2 years, it's that there's enormous value in understanding alternative versions of the future so that we can prepare for different eventualities. It is almost always safer, quicker, and cheaper to test things in a simulated environment before we do it in the real world. There are also multiple points of view when it comes to service deployment. These different stakeholders aren't necessarily conflicting, but they will have different criteria for what constitutes success. And even with these broad categories, there will be competing requirements. Local authorities and city authorities are interested in autonomous vehicles and autonomous mobility across a number of different disciplines. Simulation allows us to test these different angles, identifying trade-offs and better understanding the barriers. I'll now play a short video that explains how we've applied fleet service simulation in Endeavour, and then I'll go through some of these elements in a little bit more detail. I'll now talk a little bit more about the technology that we developed for simulating on-demand fleet services. The Amends platform has three core pillars. We utilize an agent-based simulator that's highly granular. This considers a full 24 hours. Services don't stop outside peak hours, and AV services in particular won't stop outside peak hours, so simulations and analyses shouldn't either. We also create digital worlds of the transport system. These are models which are specific to geographies of interest and include real-world data so we can analyze situations properly. This platform is then deployed in the cloud so it can be accessed anywhere and deployed right around the world. We need particular components to analyze in our fleet service simulation. We need fleets of vehicles. In this case, we're describing it as an ego fleet. We don't simulate the entire vehicle fleet, just the fleet that we're interested in, i.e. the service that we're deploying. We need to be able to simulate different operating models. For example, we might need to be able to tell the difference between rideshare services and single pickup traditional taxi services. A more complicated service might include a mixture between delivering goods and providing services for passengers. All of these things need to be taken account for, particularly for AV services. If we're going to simulate for 24 hours a day, we need to include charging and refueling infrastructure. This is particularly important as the future of AVs is very closely tied to the future of low-carbon vehicles. Our transport network models need to be representative. They need to include detail about congestion so we can recognize that Monday morning is different to Sunday evening. Finally, we need to include the demand for travel. We need to understand where, when, and why people travel so that we can understand how AV services can be deployed in the future. The technology that we've developed through Endeavour has allowed us to scale this simulation across the world. These are just three examples, from Singapore to San Francisco and even in Hamburg. The simulation itself is looking at a day in the life. This is a visualization from the output of the simulation. That dot represents a single vehicle. It's been routed through London to go and meet the passenger. We'll see the color change as it meets the passenger, from orange, which means it's on its way, to green, which means there's a passenger on board. It then routes to its destination, where it'll become available to be requested by another passenger. If we're going to simulate services at a city scale, we need to be able to do this for not just one vehicle, but for thousands of vehicles, and not just one passenger, but for tens of thousands of passengers and tens of thousands of trips. This is extremely complex and requires the development of new simulation technology, which we've done throughout Endeavour. The simulation gives us a day in the life. We understand the level of service for passengers, such as how long they'll have to wait for a vehicle. We also understand the utilisation of vehicles from the operator's perspective. We can see if we set out what to achieve what we intended and whether the city is well served as well. Crucially, we're able to evaluate both costs and revenues that allows us to understand the condition for commercial viability. This is a graphical representation of some of the outputs from simulation. Each row represents an individual vehicle, and we're able to see what all of those vehicles are doing across the entire day. We can see whether they are available for travel, whether they have passengers on board, whether they're on call, or even if they're recharging. I'll now talk a little about how we've deployed this technology to evaluate simulation, to simulate hypothetical services in Project Endeavour. Starting with an example from Oxford. Oxford's a really interesting example. It's quite a small city in the UK, but it's also a really historic city. And that means many of the streets are quite narrow and not suitable for large public transport vehicles like double-decker buses. We also really want people to switch to public transport services if we're going to meet our targets around net zero and encourage the adoption of low carbon alternatives. In this example, we've been looking at an on-demand autonomous vehicle service which might help people get to the railway station in Oxford from where you can go to London and Birmingham and other places. This is a really important rail station for both commuters, for people leaving Oxford to go to other places, but also coming into Oxford for employment, for leisure, for education and things like that. Here we've considered a non-walkable area of Oxford. So this is an area where you both can't easily get public transport to the station, but you also can't very easily walk. And whilst there are other active modes available, such as cycling, we appreciate they aren't suitable for everyone, and they aren't suitable if you have things like luggage, so on and so forth. You'll notice that the station, which is highlighted by the red dot there, is slightly to the west of the city centre, and it's the historic city centre which is particularly difficult to get through. So even in the west, where people might be able to get a bus to the train station, they might have to change at the city centre, which introduces an interchange penalty, which makes public transport less appealing, even if it is available. What we've done here is explore different aspects of service design and then report on the benefits for passengers and the costs for operators. So in order to do this, we've generated a digital model of the Oxford network, which you can see there on the right. It's really detailed, it's topologically correct. So we have all the connectivity. How do you get from one part of the network to another part of the network? We then use telematics data to describe the travel time between 2 points on the network. It's really important, as I said earlier, that this is dynamic. So it needs to vary every hour of the day and every day of the week, because a service that might be viable and attractive in an off-peak time, for example, on a Sunday afternoon, simply might not work at the busier times like commute hours or Monday morning or something like that. This gives us our supply of transport network. We also need demand. So we've generated demand for this non-walkable area, and we can do this in a number of ways. We can use synthetic techniques which rely on demographic information about people, trip making, what the household population is, how many people live there, how many people work there. But we've also generated methodologies for using mobile phone data. And this allows us to use a really, really big sample and get a good idea of why, when, and where people are traveling. These are primary inputs into the simulator, and then we can look at different service configurations and apply those to AV services. So a key thing is to look at varying the size of the vehicle fleets available to us, varying the size of on-demand taxis or something like that. You can see how giving us extra vehicles allows us to serve more passengers. Alongside that, and intrinsically linked, we can look at the makeup of that vehicle fleet. What should it contain? And we can look at this in a lot of different ways. So for example, we can look at the difference between conventional internal combustion engine powertrains or hybrid or electric powertrains. We can also look at variation in the size of the vehicle themselves. So perhaps 10-seater vehicles or 5-seater vehicles. Traditionally, we may have only considered the overall passenger carrying capacity of the fleet. Now we can look at mixed capacity, such as room for goods and room for passengers. We need to be able to look at the operating models. We need to be able to consider whether we want a rideshare service or a single pickup service. We can look at what to do with out-of-service vehicles. We can look at how we send our vehicles to recharge. Everything like that, we need to understand if we're going to evaluate a service to be deployed. Finally, there's no point in developing technology if people aren't going to use it. So we need to pay close consideration to passenger service, passenger experience, if we want to deploy AV passenger services. So some examples of the insights we gain from doing this. First of all, we can look at the value of adding additional vehicles to our fleet. We can look at how many trip requests could be satisfied over a 24-hour period, and we can look at the marginal benefit of additional vehicles. Here's an example. On the vertical axis, we've got the percentage of trips that have been requested that have been fulfilled by our vehicle fleet. And on the horizontal axis, we've got an increasing fleet size. As you might expect, with more vehicles, we're able to satisfy more trips in this particular area, which, as I mentioned, is Oxford in the UK. However, you'll also notice the relationship isn't linear. We don't get the same proportion of additional trips served for each additional proportion of vehicles. In fact, as the vehicle fleet increases, we have diminishing returns. That tells us that the benefit of our investment in additional vehicles isn't always the same. That ROI doesn't necessarily scale. That's really important if we're trying to deploy a viable service. But what about the passenger experience? How does the passenger experience vary as we improve our vehicle fleet? And we can look at that as well. Here's the same example, and the black line you see there is exactly the same from the previous slide, where we've got diminishing returns as we increase the size of the vehicle fleet. In this case, we have a more linear, not linear, but a more linear relationship between the passenger experience. And in this case, we're equating passenger experience to the wait time that they experience, the time they experience when they're waiting for a vehicle to come and pick them up, and in this case, take them to the station or take them from the station. So we can see we may not want to add additional vehicles if we just purely look at revenue generation from a trip fulfillment perspective, but it may be what we need to meet certain passenger wait time thresholds. And really, this passenger experience is so key to us if we're thinking about deploying AV ride-sharing services. And there are lots of ways we can use a simulation to design for different passenger experience. We can look at changing employing certain service level agreements around wait time. We can look at permissible detour for rideshare services. We can look at arrival time constraints. In this case, that's very important. We're considering a train, a service to and from a train station. There's no point in requesting an on-demand AV shuttle to take you to a train station if it's going to get you there after the train has departed. We can also look at different vehicle constraints. If certain passengers have certain mobility needs, which means they need a specific type of vehicle, we have to build that into the simulation as well. Otherwise, it's not going to reflect reality, and our deployment of AV services is not going to go very well. One example is around the maximum passenger wait time. So service operations often have particular thresholds, like a service level agreement, which says our passengers can't wait more than 10 minutes, for example, or 20 minutes. We might also want to play around with this if we're trying to understand what we can achieve with a constrained fleet. For the same example before, in this case, we'd set a global maximum that said no passenger should have to wait more than 20 minutes for a trip. We may decide that that isn't good enough. It may decide that if people have to wait 20 minutes, they're not actually going to use our service, and therefore we need to make that more stringent. If we do that, for example, introduce a maximum wait time of 10 minutes, we can see that all of a sudden our trip fulfillment has gone down, and to achieve the same level of revenue, same level of service in terms of actually providing something to passengers, we need more vehicles to do it. In this case, we need something like 27 vehicles when the maximum wait time is 10 minutes, compared to 15 vehicles when the wait time is 20 minutes, if we want to serve around 70% of the trips. But there's no point in having a really granular simulation and a really detailed set of results if we don't dive into them a little bit more. This is another way of representing that data there. The top bar on the horizontal shows us the split of passenger wait time experienced when the global maximum is 10 minutes. So we can see here that even though the maximum a passenger will have to wait is 10 minutes, a quarter of them are waiting less than 2 minutes. So if we look at the bottom bar, this is when we've set the global maximum to be 20 minutes. And we can see that even though we've done that, more than 50% of passengers are still waiting less than 10 minutes. This allows us to get a better idea of what sort of service we're providing and make important decisions around how we deploy our vehicles. We certainly don't want to spend additional money on vehicles if they aren't going to be properly utilised. An important part of Endeavour is making the technology so it can be rapidly transferred to other cities. And I'll show you one example of how we've done that to Birmingham in the UK. In this case, we've been looking at a scenario about how we can supplement public transport. Even the most well-developed rail networks have some areas that have got little or no service. Fixed route bus services are much more flexible than heavy rail and light rail services, which require significant infrastructure, but they're expensive to maintain, particularly if they're maintained at high frequency and when they're utilised off-peak. We find when service levels drop off-peak, if perhaps they're only half an hour or every hour, and the buses are frequently running empty, then that's not a very cost-effective way of giving people access to the rail network. So this is an example where we think maybe autonomous vehicle deployments could help, particularly if they're low cost without labour associated with them. And that's what we've done. In this case, we've simulated two specific examples of a fleet of 3 vehicles and a fleet of 10 vehicles. And they're all moving between regional rail stations in the Birmingham area in the UK. This is just a visual output from our platform, but it gives you an idea of the level of detail with all of those vehicles traversing the network over a 24-hour period, although in the real world, they wouldn't be going quite that fast. Here are some of the outputs we get. So here we can see that a fleet of 3 AVs could service more than 300 journeys in a day. And this could provide much needed access to the wider public transport network. Could perhaps be limited to those who really need it, such as those who can't access active modes like walking and cycling. However, we also see if we're able to encourage rideshare, a fleet of 10 autonomous vehicles could serve well over 1,000 trips per day. And this could provide a really viable alternative to low frequency fixed routes, both reducing our costs and improving the passenger experience. We can show that simulations give us wait times averaging only 5 minutes and with more than 85% of the vehicle mileage spent with passengers on board. So massively reducing the dead mileage that might be associated with some of the fixed routes. So Endeavour's provided us with a comprehensive evaluation of different operating models for AV services. It's helped us to better understand the conditions and barriers for deployments, not only from a fleet operations perspective, but also from a transport planning perspective. It's also given us an approach that means we can very easily simulate AV services across the world. We can deploy the simulation pretty much anywhere, which allows us to do a rapid deployment before we spend any money on the AVs themselves. Thank you very much for listening.
Yeah.
That was the presentation on Project Endeavour. And Oxford, Birmingham, the cities of UK, were serviced with AV ride sharing, and we were able to understand the approach, the effectiveness, the wait time, and Immense developed the simulation tool to carry out the analysis of the potential services outcome. Earlier, we talked about services that could be provided in large cities. And so we looked at the infrastructure and what sort of services would be conducive going forward. On the other hand, if we look at Korea, where we have population density and we have public taxis and public buses, they have a very dense road network as well. And I can't do an apple-to-apple comparison with UK, but at the same time, we need to understand what sort of models that Korea can choose, and I think their work would be a good reference in carrying out more detailed analysis. So we were able to hear 6 different presentations. So some of the projects have been concluded, some projects are in progress. So I think it was a very useful session for us to have a better understanding of what's happening in the UK in the area of simulation, in the area of CAB, and also what sort of environment can we build and what sort of data we can collect so that we will have some analytical tools to produce outputs. And at the same time, we can imagine a harsh environment and where we need to do a pre-analysis about the dangers, the hazards. And so what's helpful is also the cost analysis as well. And not just UK companies, but also Japanese companies, auto OEMs are very much involved, and other countries, companies are all collaborating to overcome the challenges of future mobility. I want to thank the 7 companies who have presented today. Thank you. And on this note, I would like to close session 2. And the next session is called panel session, and will begin at 4:30. And the title of the panel session is Service and Business Models for Future Mobility. This will be moderated by Sung-Soo Hong, Professor of Seoul National University. And just wondering if there is a Q&A session. Unfortunately, or possibly if the speakers are joining us online, it could be possible. But unfortunately, the speakers have provided us with pre-recorded videos, and so they're not really here live virtually with us. And so although in the program we have stated that there will be a Q&A session after the presentation, we'll skip that and we'll just resume again at 4:30 Korea time. UK time, it's 8:30 in the morning, and we'll begin the panel session. And so, did I say everything correctly, Professor Hong? And of course, I know that you have numerous things you like to ask, but I think that the authors were quite considerate because they provided us with their email addresses. So feel free to reach out to them directly, or possibly you could send the questions to KSAE, and we will route the questions to the right speakers. And once they reply, we'll send those answers back to you. Without further ado, we'd like to close this session, and I'll see you back here at 4:30.
예, 여러분 안녕하세요.
Hello, everyone.
제가
I am Hong Sung-soo, professor of SNU. We successfully completed session 1 and 2. We will go on to session 3, panel discussion.
패널 토론의 주제는
The theme of our panel session is Service and Business Models for Future Mobility. Actually, through our presentations, and then I always feel that future mobility will require a lot of change and technology transformation, and it will require multifaceted technology. And such technology, will it live up to our commercial demands? And also, are these technologies sufficient in meeting the demands of consumers as well? So in the morning session, Dr. Cha said that there are many companies carrying out mobility services, and there was a full list of companies, and all of these companies are working in this mobility market that is not fully developed yet. And I was wondering if all of those companies could survive and develop. And we are trying to create seamless mobility as a service business and new services using AVs. And for these services to be materialized, it will require some time. And will these companies be able to overcome such chasms, especially small and medium-sized companies that have limited technology and resources? So this is a challenge and concern for us. So during this panel discussion, we will talk about not only technology, but we need to reflect on the situation to think about strategies that will be needed in the future. And that was the background of selecting this topic for our panel discussion. Through the presentations, I'm sure you felt this too, that Korea and UK are very strong in mobility area. There are areas that we are each strong in, and we may complement one another in, and we would like to create synergy effect through international cooperation. So we hope that we can find and identify areas in which we can work with one another. Before we begin the panel discussion, I wanted to introduce our panelists to you. Since I have already introduced myself in the morning session, I will not introduce myself. I'll be serving as the moderator of this session. And first, we have with us panelists from the UK, so I will introduce them first. For the past year, CEO of Cenex, Robert Evans, has been working to prepare for this conference for the past year with me. And Cenex is a not-for-profit consultancy and research organization, and they are holding various low-carbon vehicle technology conferences, leading innovation in this area. And the other panelist is the Chief Product Officer from Immins, Dave Williams, and he presented in the second session. And our third panelist from the UK is from Connected Places, Catapult, Tom Webster, Principal Engineer. And I have already introduced our two speakers in the previous session, so I will not introduce them in the panel discussion. And for the Korean participants, I will explain and introduce them in the order that they are seated. First, we have Ju Young-seop, chaired professor at SNU. Dr. Ju is chaired professor at SNU, and he was the representative director of Hyundai Motors, and also he was the managing director of the Office of Strategic R&D Planning at the Ministry of Knowledge and Economy. And he was also the government, served at the government of SMEs, Ministry of SMEs, and he is contributing greatly in the automotive industry. And next to him, we have Kang-nim Choi, Senior Vice President at KT. Kang-nim Choi at KT is working on autonomous driving and logistics. And he is working on various future strategies for the future of KT. And next to him, we have from Move, CEO Min-seok Choi. And his English name is Mitch, so he's Mitch Choi. The company Move is a startup company working into mobility and travel, connecting these two areas for future-oriented services. Mitch Choi worked for 17 years at Samsung Electronics, and he holds an MBA from MIT. And he worked on various M&A activities in the field of mobile services at Samsung Electronics, and then he set up his own startup company. Lastly, we have with us Christopher Chang, Managing Director at Kakao Mobility. Christopher Chang is a Managing Director of Kakao Mobility, and he is in charge of strategy and business development for the mobility technology innovation. And he received a PhD at Caltech, and he has worked in companies such as Hyundai Motor Company and Samsung Electronics and Qualcomm. And he has contributed in many leading organizations in Korea. And he is now working at Kakao Mobility, trying to establish a platform business in this area. And we have 7 panelists for this panel discussion. Then I will now like to show you my presentation slides. We have not allotted a long time for our panel session. We only have 90 minutes. And I would like to provide a short presentation on the background and the purpose of the panel discussion. And I will give each of our panelists 5 minutes to give their initial talk. I know what they are going to be speaking about in general, but I hope you are able to hear the details of their discussions. And the title of the panel discussion is How to Make Service and Business Models for Future Mobility. And to explain what this means, it is about making a sustainable transition to ultimate future mobility. And compared to what we had expected, it might take longer. And during this time, we need to make a sustainable transition and also a successful transition, especially for companies that may not have enough R&D resources and time compared to large conglomerates. SMEs need to overcome the chasm that requires some time and also resources. During the first part of the panel discussion, the speakers will be speaking about these themes. They will be providing a critical analysis on current mobility industry, and as was mentioned, for ultimate future mobility. And for us to go toward that goal, companies need to be successful. And they need to provide successful services to their customers. So we would like to gain some insight for such a transition. And in the process of transiting to a ultimate future mobility, what are some areas in which Korea and the UK can cooperate and collaborate with one another? So that's the main purpose of our panel discussion. This is the concern that I have on the mobility business. Many people may empathize with this, or some may not agree, but in any case, this is related to why I prepared this panel discussion. I think that the current mobility business is in a stalemate. While we engage in mobility business, in the beginning we thought of car sharing and ride hailing. So these are the two major business models, but due to the pandemic situation, there has been a slowdown in car sharing business. Then how about ride hailing? It was thought to be a very new business, but this is also similar to other platform businesses. So there are some doubts about the novelty of ride-hailing business. Then how can we create new business models and services utilizing future mobility? Second, Dr. Choi and David Wong also mentioned this during their presentation, that there are many companies and SME startup companies that have ventured into the mobility business. But many of these companies, while they are trying to provide services that appeal to the public, if you look into the detail of their services, it is on the premises that there will be level 4 and level 5 AV services. They are stating that they will provide these services once we enter into level 4 and 5 autonomous driving. We saw during the presentations on the communication that it will take 3, 5, and in some cases 8 years for the technology to fully sophisticate and mature. And so how are we going to overcome this delay? And those in the auto industry, especially SMEs, I think this is a common crisis that they are facing. Tier 2, Tier 3 suppliers that supply components to their OEMs, they are being required to move to a net zero manufacturing. And the EV market has opened up, but it is not a big market yet. And these small and medium-sized companies need to make investments based on the prospects of the future, and they cannot get immediate returns, yet they are required to make these investments early on. And this can be applied to future mobility. We are thinking of services that go beyond ride-hailing and car sharing, and the big market has not opened up yet. And SMEs need to make investments for the future and prepare for the future, and they need to survive, yet the future has not unfolded yet. On these themes, we are seeking answers, and that's the basic intent of our panel discussion. So we would now like to ask Mitch Choi to give the first discussion.
하시면 됩니다.
네.
Hello, I am Mitch Choi, CEO of Move Corporation. As Professor Hong mentioned during his presentation, I think there's a stalemate in the mobility service. And in order for us to think about the future, I think what's helpful is to benchmark the growth trajectory of the smartphone market. So can someone pull up my slide, please? So can we have the Move's presentation? And if we can move to the next slide. For me, when I talk about mobility and telecom, I think I find a lot of similarities historically. If we look at transportation and telecommunication, they have to develop for the society to develop. And so ultimately, there is a link. And there's also a connection. And connection is an infrastructure which serves as a foundation for future growth. Next slide. And more specifically, so in the case of telecommunications, it's really connecting people to people. And what they use is person's voice or data. When it comes to mobility, it's really connecting people to people or product to product. And for the smartphone, and the reason why I say we should benchmark smartphone is the similarities, because they brought mobile phone, communication, and information technology and created smartphones. And so before the emergence of the smartphone, you were able to bring a lot of heterogeneous and a lot of other verticals into the smartphone area. And so you were able to go beyond hardware, and you were able to provide a lot more. And so there are only a few handful of companies that are doing smartphone hardware. But because of the connectivity provided by smartphone, you have companies like YouTube, Netflix, and Instagram, and they are actually creating even much bigger value. So now, the current status of our mobility service. We have these heterogeneous industries, and it does not just stop at connecting, but you have to also think about really building that infrastructure that connect. And what is the essence of the mobility? It's really bringing different verticals together. And I think we still have a lot more to do to make sure that we have a full mesh connection. And a little bit down the line, as we have autonomous driving, and once again, going back to the smartphone story, you do need to have a thriving hardware business for AV as well. But that will not be enough, because when you have a compact device, which is CAV, and then that has to be serving as a platform so that other services and contents can be put on that platform, and that may actually even generate greater value. As a result, for us, there are so many industries, and for us, for mobility, which industries are directly impacted? And what we have entered, and this is our business model, is really to bring mobility together with travel. And so if we live in a post-corona COVID world, and you need three things when you have or planning for a overseas travel. You need to book flights, hotels, and local transportation. And all of you, I know that you have no trouble actually booking flights and hotels to take you anywhere around the world. However, still, when it comes to local transportation, the mobility service, there isn't really a viable infrastructure that allows you to pre-book local transportation. So for now, the available services are ride-hailing, taxi-hailing, but this is really everyday mobility. And so from a location of where you reside, it's a convenient mode to travel short distances. And so if we look at other applications, taxi may not be the best option. And so you also have a rental car service. And if you go to other countries, it's not very often that you can actually drive directly. But we already have a very good service, which is the chauffeur service. If you're not able to drive, and if you don't want to drive, then you bring the rental car service and also have chauffeurs, drivers included as well. And so we already have this type of services available, but we didn't really have a global platform that was connecting all of these people together. So moving to the next slide, what we did was to reach out to the rental companies and also reach out to drivers. And we were able to build a global platform. And right now, we are in 11 countries and 40 cities in Asia. And we want to go to US within this year, and then early next year, Europe. And this is a plan that we have for overseas expansion. And for ride-hailing, if we do a comparison, currently we don't have a single platform. So by region, we have fragmentation for ride-hailing. So from a user's perspective, you actually have to download different services if you travel to different regions, and you have to register your credit cards by service, and this is very inconvenient for users. And so what we do is really a integration, and we want to make sure that we understand the need of the user and user convenience, and we provide a single platform irrespective of the different service providers per region. And we also have working partnership with Korea's rail service, KTX, and this was commercialized from July. And so this is a pickup service for KTX users. Whether you are a Korean national or a foreigner, you could travel from Seoul to Busan and via KTX, but that's not your final destination. So your final destination would require you to actually use a different transport mode to take you from KTX station in Busan to your final destination. And so for the first time, we work with Korail to provide also pickup service for KTX users. But we don't want to stop there. We also want to have business partnership with URail as well. And lastly, if you are traveling overseas, air transportation is something that we have to always rely on. And so we want to make sure that we have air transportation booking and also local transportation booking done in a single platform, and also to support various heterogeneous services as well. And when you do this, right now, you want to travel overseas. The mobility always stops because you actually have to use different service providers, and you also have to book each journey. But for us, we don't want this inconvenience. We want to have seamless connection, seamless end-to-end connection. Thank you. So you just heard from Mitch Choi, and he really wanted to talk about the end-to-end seamless interconnectivity so that the users will have a integrated trip planning, and it doesn't have to be fragmented. I think this is something not requiring an innovative technology, but with more automation. It is service that will be well received by users. As I mentioned, ultimately, in order to be part of the future mobility landscape, automation has to be deployed as soon as possible. And so we also want to do mass deployment as well. And from this perspective, we also have Christopher Chang, and he's going to talk about Kakao Mobility Service.
반갑습니다.
It is a pleasure to meet you. I'm from Kakao Mobility. I'm in charge of future business, and my name is Christopher Chang. Can you show my slides? Based on my slides, I would like to provide my opening remarks. First, on what Kakao Mobility does, and then I'm going to talk about the mass-scale service deployment that we are considering. Next slide. Next. Kakao Mobility carries out various mobility services, and we are a platform company here in Korea, and we're trying to move everyone's life smarter and faster, and we provide various solutions, taxi, driver service, and To support this, we have navigation, parking solutions, and micro-mobility, shuttle businesses are other types of business models that we're providing. And autonomous driving is still in its infancy, but we are preparing for this business. If you go into the details, in Korea, Kakao Mobility has diverse services that it provides into a large scale. Taxi, driver, navigation, and parking services are the services that grew very quickly. And our challenge now is how are we going to connect this with the autonomous driving and AVs? So to give you an example, taxi service, a taxi hailing platform, it utilizes backbone functions. And you can think of AV shuttle. If you think of AV shuttles, the payment, routing, and the placement of the shuttle vehicles will utilize the data that was built up through the taxi hailing platform business. For example, here at this Samsung complex, which is a big complex, you can utilize this data to show and indicate where it is most convenient to grab a taxi. And it isn't necessarily the gate in which the passenger is trying to come out from. It should use information on the AV route, and that should be used as a variable in order to determine where the passengers should get into the AVs. And we can use the taxi platform business information and data. And for the driver service, we utilize a flexible pricing system, and end users can bid for the designated driver service and determine the pricing. And in the AV service, we can provide a service that has a flexible pricing system, and we can utilize bidding as a pricing mechanism for passenger and mobility of goods even. Also, for mass-scale mobility service deployment, we need parking and infrastructure for such parking. Kakao Mobility has large-scale parking lots, and we have a charging system. We are providing this as a all-in-one service, and for mass-scale deployment, you need to have parking infrastructure, the supporting infrastructure. It's not just the charging system for taxis, and we have used these parking lots to provide accessibility of the taxis, and it adds to the efficiency of the operation of taxis by having our own parking infrastructure, and this can help in the last mile delivery of cargo. Also, navigation plays an important role too. At the moment, general users can utilize navigation service, and many users through mobile applications utilize such navigation services. And recently, on HTMap, we are making a lot of preparations. AVs, for them to have stable and safe operation, we need high-definition maps, and we have the infrastructure to support this. Not only do we need to set up maps, we need to maintain and upgrade these maps, and this has to be automated, and we are preparing for the automation of these maps. So taxi services, designated driver service, parking, and navigation services will be the underlying technology and functions to enable AV services in the future. CEO Mitch Choi explained something that is aligned and that is similar to this. So as users move from one location to another, as they move from A location to B location, they thought of the route. But now we are thinking about seamless experience and the continuity of the experience. Kakao Mobility at the moment provides individual services at the moment, such as taxi hailing service and flight booking service and train booking services, train ticket purchasing systems, and it's all fragmented at the moment. However, it needs to be integrated to provide a seamless experience to users, and we consider this to be our ultimate goal too. Next slide. Next slide. So this was explained, so I will not cover it in depth. And aligned with these efforts, we are making preparations for future mobility services as the ones introduced here. Before we go to mass service, you have to prepare for a lot of things. And one important part is to consider various users, and various users need to experience a service. And there might be hesitancy and caution about adopting such technology. And it's not just about advancing the technology itself. We need to make it convenient for the users to use, and they should also feel emotionally assured when using these services. So we need to create an environment that provides such assurance. And we are providing such services at Sejong City. For the first time in Korea, we launched a paid service, an autonomous driving service. And this year, we are planning to provide various service models in various regions. And the feedback that we gain through such services will be reflected in our new services, and we are trying to lay the foundation to launch this into a mass-scale service. And in an effort to do so, last month, we launched Kakao Mobility Autonomous Alliance Program. And for us to go toward a mass-scale service launching, we are working to have these backbone technologies such as autonomous software, hardware such as the vehicles, and control, teleoperation services, and HD maps. And so we're trying to create partnership for this. For us to carry out and roll out mass services, we need to have a united team, and you need to have a strong team with strengths in various fields, because you cannot roll out mass-scale services with just a product and a technology. You need to have a teleoperation that provides secure servicing, and AVs and AV technology has to be established. Also, Mitch Choi pointed out an important point, which is autonomous vehicles are like smartphones. You will have the hardware, and for hardware to be expanded, you need to add on various service applications. So Kakao Mobility will provide the the environment that enables the utilization of these various applications so that these services can develop on top of this platform, and new business models can be created. So we heard from Mr. Chang about service integration. So we heard about the aspects or viewpoints of Korea. So we will now move to the UK. And here, two panelists from the UK.
Mr. 로버트 에반스 먼저 발표.
First, we will hear from Robert Evans.
Hello. Hi, Robert. Would you take the turn? about this panel discussion?
Thank you. Can you hear me okay?
Yeah, sure. I can hear you very well.
Thank you. Great. Well, thank you very much. Welcome, everyone, and thank you for the opportunity to present today. So next slide, please. That's right. This is an image of how our children see future of mobility from Catalonia, as basically showing Barcelona, and I think it shows a very interesting image of future mobility. We see drones flying in the air for robo-taxis, and we see vehicles on the road. What's interesting about this is that we see both conventional walking along the pavement, we see bicycles, but then we start to move into a zone for automated, connected, and electric and shared vehicles. We're seeing the ability to hail here through control systems. You're seeing the vehicles charging, being electric, and you're seeing taxi operations, but also conventional vehicles operating in the middle lanes. Now, this is really a good image in that it shows both what the opportunities are, but also the challenges. The challenges here is that our road structure in Europe is not split in this way. We have many old historic cities with maybe only one lane for traffic, not the ability to segregate traffic. So we have to have a situation where we have a mixed mode of operation between conventional vehicles with drivers and highly automated vehicles. And herein comes one of the central challenges. Also, our road structure is very narrow in many cases, and that can lead to connectivity issues and street canyoning. So we do have some technical challenges, as well as the need maybe to restructure some of our road networks to accommodate future mobility. Next slide. So the next slide I'm hoping you can see is that that what we are looking to build with future mobility is a very complex future-enabled system. So in order to plan for these many scenarios for the future, we need to build on very, very firm foundations. And as indeed, drawing across from the building of a skyscraper, we wish to build a skyscraper of functionality for future mobility. We need to build on very firm foundations. Next slide. So I consider this really that there are two sectors to look at and four foundation areas. The two sectors are the zero-emission personal mobility, and this we've talked a lot about the robo-taxi application area, and the other area is the zero-emission automated logistics. And this has come up in the earlier presentations, and I want to talk a bit about this as well. There are four foundation requirements. Sometimes they're called challenges, but I'll consider them the opportunity areas that we need as our community now very strongly to address. These are the technology in terms of both the verification and validation of the performance of the technology, but also the development of the supply chain to provide that technology. The second area is the regulation, and the regulation has two parts. It's the regulation to which we as a technical community design our products and test and verify our products, the engineering rules that we work to, but also the regulation that allows customers, be they a city or a logistics operation, to roll out technology, knowing that they can consider within a legal framework that to be reasonably safe or safe assurance enough and cyber insurance enough to be able to make that investment. The third area is the business models, and we've had some presentations covering this, and this is a key area, which are the early moving markets and what is the value that can arise from those. And the final area is consumer, or I would say customer acceptance. and that is customer acceptance in terms of those traveling through using zero emission personal mobility, but also customer acceptance in terms of operation within logistics locations. Next slide. So I'll borrow David Wong's slide from earlier to sort of highlight the two aspects that we have at the moment. We have on the left-hand side passenger cars fitted with automated driving systems, and then on the right-hand side we have the higher automation level operations such as the robo-taxis and the logistics. We've heard from David about the evolution of functionality, particularly the ability to upgrade functionality that you will get from your passenger car. And we've heard from Thomas about the opportunity about automated valet parking. And I'm very pleased also to hear from the work of Kakao Mobility to help enable that important application area. At the moment, it's a challenge. I have a Model 3 Tesla. I paid £5,000 extra for the full automated pack and for the upgrades that I expected for the life of the vehicle. I know it beeps at me to tell me that maybe I've missed an incident, that I would have been unsafe. It seems to control my operation along the motorway to prevent me hitting other cars, but it's difficult to fully value that benefit as a consumer, and so many consumers pay extra for extra batteries rather than for extra automated features. So it is a challenge for the car industry to translate that extra functionality into extra money that the customer will pay. In the automated passenger section, we'll move on to the next slide, please. I want to talk more about the automated logistics opportunity. This, I think, is a really critical area. We've heard about the challenges from the robo-taxi side. Here we have a range of early application areas that are being progressed in the UK and elsewhere. On the left-hand side, we have the automated delivery function. So this is this is a trial by a UK company called Westfield, and they are doing the delivery for, this is with what's sponsored by Waitrose, but in each of the little boxes here, this could be Amazon parcels, it could be anything that you are receiving by online delivery, but this vehicle will move to a location. It can't hand you what is in the box. It would have to send you a message to come out to receive the box, or you have to change you have to have a method that links this. It can't knock on your door and post it through your letterbox, but it can bring your products closer to you. And the same again with the Nuro shown here with Kroger, one of the main US supermarkets. The top smaller vehicle is a delivery vehicle, again from Westfield, but we have a number of these sort of smaller delivery vehicles, also Starship in Milton Keynes. This particular vehicle links to an automated pharmacy. At the moment in UK hospitals, we have a lot of highly valuable drugs for treating different medical conditions. They invariably sit on a shelf and go out of date, and there's a loss of a large amount of money. So there's a desire to turn pharmacies in hospitals fully automated with so that they know all of their stock and that they have robots to take that stock and hand it into these kind of delivery vehicles, which can then travel through the hospital to the ward to deliver the drugs that is needed by the nurses and doctors. Then also we show at the bottom, and we see again, you can see it's actually an adapted pod that would be used for moving for people in, but this particular one has been adapted for functionality at the airport. Is demonstrating both the important sweeping capabilities to prevent accidents and debris that can impact planes on runways, but also can be doing, for example, the dolly kind of delivery of food to the planes, or taking ultimately suitcases away. So There again, functionality in a controlled environment. And the final area that is probably the most relevant at the moment is logistics in ports. At the moment, we have a big problem in the UK and I gather elsewhere where there are not enough drivers to take away containers that have arrived at port. So the ability to not have drivers, but to be able to move those containers around port operations in a controlled environment with 5G connectivity. This would seem to be one of the earliest and most promising of the business opportunities for automated vehicles. So I think my central argument really here is that we should look to logistics as the big opportunity area because you can do controlled environment with high levels of connectivity, geofencing, and control center operation can establish for longevity good business model opportunities. Next slide, please. So I think really we need to look at these 4 pillars of technology, regulation, business models, and consumer acceptance. And I do think there are tremendous opportunities for the UK and Korea to collaborate in these 4 areas. And I would suggest that logistics is one area, but obviously with the expertise we have in the room today, we should also continue to look at the parking opportunities, and we should look at the robo-taxi opportunity as well, because ultimately that is the big opportunity area that we need to unlock. So thank you for the opportunity. I look forward to speak today, and I look forward to participating in the panel.
예, 감사합니다.
Thank you. Robert has been able to classify and itemize various issues related to future mobility, and he also talked about the expertise that's required in the respective areas.
Position.
Good afternoon. Do we have some slides?
그 데이브 윌리엄스 슬라이드 좀 올려주시겠어요?
They've gone again. Great, thank you. Good afternoon. It's very nice to be here. My name's Dave Williams. I'm the Chief Product Officer at Immense. If we can go to the next slide, please.
다음 슬라이드.
Thank you. So I want to provide 2 quick bits of context. I'm going to talk briefly today about the role of small and medium companies, small and medium tech firms, and how they can contribute to this transition to future mobility. And more appropriately, why should they be contributing to this transition to future mobility? I work for a company called Immense. We're a startup technology company in the UK who've been operating for about 5 years now. In the talk before the break, you heard me talk a little bit about our technology platform and how we've been developing it and applying it within Project Endeavour, which is an autonomous vehicle rideshare service technology trial in the UK. The technology that we've built has been associated with connected and autonomous mobility. But to properly commercialize it, we were also applying it to a wider variety of use cases in transportation infrastructure. And this includes immediate, important, but sometimes mundane problems, such as roadworks planning. It's not quite as future thinking necessarily as connected autonomous mobility, but these are all intertwined within the same mobility ecosystem. If we go to the next slide, please. Project Endeavour was a really exciting trial of autonomous vehicle technology, but it's not just been about the technology. It's also been about public opinion, it's been about safety, it's been about simulation, it's been about the regulatory environment, it's been about all the key components, or as Robert described, the pillars that are required for us to transition to future mobility. What I want to do is talk briefly about 5 key takeaways, both from my personal involvement in the program as a long-standing transportation researcher and a practitioner, but also as part of a small and developing technology firm. So if we go to the next slide, please. So this one should perhaps be self-evident. We don't develop technology for the sake of developing technology. Many of us are technologists. We get very excited by technology, but that's not the point. There's been a lot of excitement about connected autonomous mobility. There's been a lot of excitement about AV technology in particular over the last 5 or 10 years. We've lauded the benefits. We've been really keen to develop an industry around it, and we've been really well supported by UK government in particular. But without a demonstrable market for the technology, without a way to commercialize and make money off the technology, this is not a sustainable activity. We won't keep on developing this technology unless there is a better purpose for it. So we go to the next slide, please. Those most deeply involved in developing the technology aren't necessarily considering the commercialization that's required to make this work. And when it comes to highly and fully automated services, currently we're thinking primarily about the barriers to deployment, or historically we thought more about the barriers to deployment. So the technology barriers and the regulatory barriers. How do we make this technology work in the real world? How do we deploy the services? How do we get them working? What we need now, and what we've seen increasingly over more recent years, is a need to consider how we better commercialize the technology. So again, this feeds into point one. If we're going to work through the technology barriers, there needs to be a purpose at the end of it. Thirdly, and this is something that I'm quite surprised comes up a little bit too much, and should probably be self-evident. When we talk about CAM technology, highly and fully automated technology, we sometimes make the mistake of thinking about it as a single technology, a monolithic block of technology. This is absolutely incorrect way to consider highly and fully automated CAM technologies. The technology innovations that we've undertaken are numerous. We have hardware and software, sensors and algorithms, mapping, data services, measurement, validation, and whether it's retrofitted vehicles or autonomous pods, we've got multiple types of technology being developed. And this means that the routes to commercialize and exploit the technology that we've been developing in the name of highly and fully automated vehicles, are much more numerous than the market itself. And if we're fixated on CAM and the CAM applications of our technology, then we're going to be missing out on routes to commercialize. What SMEs can do, and why they should be involved, is they can take advantage of a buoyant market around CAM. They can take advantage of the excitement around CAM, but develop really diverse revenue streams that enable them to prosper and thrive far beyond the CAM industry. So go to the next slide, please. So we're coming from a situation where we have wide and varied technologies under development, and we accept that in order to make these work, there needs to be commercialization. There needs to be people using the technology. There needs to be the exchange of, there needs to be benefit. There needs to be a value proposition involved with that technology. In order to do this, we need to have a much better understanding of who the customers for our technology is. And it may be consumers. We've heard some really interesting things already this afternoon about the mobility ecosystem and the interplay between business and mobility consumers. It may also be business itself, and it may be government. But it might not be all of them together, and how we commercialize our technology and how we prosper as an SME will change based on who our ultimate consumers are. We also can't limit ourselves in that respect. We can't limit ourselves to a single value proposition. So we've seen where we've had struggles with robotaxis or we've had disruption in the market. We need to consider how our technology adds value in adjacent and other markets. We have many technologies, we also have many markets. And next slide, please. Embryonic and emerging markets are always difficult to predict. We have numerous external factors and we don't have a track record of stability for us to lean on and become confident in the direction it's going. And this requires agility. So if we're going to make the most out of connected autonomous mobility, if we're going to action this transition to the future world with it, we need small and medium companies involved. We need startups involved because they are crucial. They are able to react. They are able to be agile. Small tech firms have a lot of disadvantages in the marketplace, but through a partnership between the larger technology firms and the smaller technology firms, we can achieve a better outcome because we can play to their strengths. Thank you very much. Looking forward to taking part in the rest of the discussion.
Thank you very much, Dave. These are really, thank you for bringing up these issues. They are very insightful. I 100% agree with you. 저희가 너무 시간을 많이.
We have used a lot of time already, so I'm sorry for the remaining 3 panelists. I think we will have to go into our discussion. So on the issues that Dave has raised, I would like to ask a provocative question. The current mobility situation, for the industry to grow, the market needs to pull and technology needs to push. But are customers really pulling us? Or is it just the technology pushing us? So that was a thought that I had. And from that perspective, we need to find the right direction. And I would like to hear from Professor Cho on what the correct direction may be.
Yes. Thank you. I think that's a very salient point, and I really enjoyed listening to other panelists. In terms of the market pull, the tech push, whether the market should be pulling even harder. Now, in some industries, it's actually pushed by technology. So you don't have market pull, but you have tech push. And that is why when we're talking about the AV service, we still don't know whether it's going to be led by market push or tech push, and market pull or tech push. And so I think, as our other panelists, and even Dave mentioned this, is that we still cannot fully predict the future. And so I want to say that, first of all, we're here to talk about future mobility. And so when discussing this topic, I think we shouldn't just focus on one thing, which is connected and autonomous driving, because I think we really have to consider other elements as well. Because when we're talking about AV, and normally people talk about urban driving and passenger cars, and the AV urban driving, I think it's not really going to happen in full swing until 2030. There are some people who are very negative, and they say that it's never going to happen, because you really have to fundamentally change the existing urban road infrastructure. So some people are extremely pessimistic about this, and we have a lot of skeptics in the auto industry as well. So in the meantime, as we look at autonomous driving, not just talking about SA level 3, 4, or 5, what I want to say is really, I think it's really the purpose-built special purpose vehicles will be the first implementation deployment of autonomous driving. So we heard from Robert Evans about the shuttle service or the delivery, and also the logistics applications, and also moving the containers in the port area. So it's a contained, controlled area. It's not high speed, it's low speed, but everything's under control. And autonomous driving is possible. This application is possible in a near term. And so in a confined or controlled environment, I think you can build an infrastructure to support these type of new services. And so if you take this approach, and you can also see many different applications in this area as well. So I think when we talk about future mobility, I don't think we should just bet all our chips in one thing, which is autonomous driving. for passenger or personal autonomous driving, I think we should really think about other types of applications. And so in terms of the safety, I think we will see more advancement taking place in V2X management. We also will do a lot more in fleet management, and also there's going to be a dramatic improvement in the navigation system so that we will have smart navigation in the future, whether it's VOD, e-commerce, or insurance. Or in the energy sector, we have vehicle to grid. We also have many different types of services that are currently being developed. And I think they also need to receive attention as well. So our job is to really identify as many use cases as possible. And once you have a huge pool of use cases, then you can also build a viable business business model from that as well. And you also need to address the lifestyle service issue. You also have to link that to payment, finance, and you also have to bring other daily services into this overall framework. So that's my desire for the future. Thank you.
To add on this issue? 이게 잘 안 들리는 것 같으네요. 예, 라이브 세션이라 어려움이 좀.
Since this is a live session, I actually asked a question to Dave if you'd like to speak on the topic. If you don't have anything to say, then I'll just go to what Professor Ju just mentioned, where he talked about mobility. And it's not a small platform business. We're really requiring a huge investment and building out a huge infrastructure. So in this respect, what would be the positioning for the SMEs? And I know that we have Kang Lim Choi from VP of Korea Telecom. He can talk about this.
Hello, everyone. I am Kang Nim Choi, in charge of AI at KT. I am one of the conglomerates that's joining here in this panel discussion, and I've been asked to speak on behalf of small and medium companies. And Professor Hong talked about the three purposes of this panel discussion, and we have been talking about the challenging factors for EVs, AVs, and ride sharing and ride hailing services. And I do understand that it requires big investments up front. It will not be easy for small companies. And I think that large telcos like KT can contribute here. We heard about car hailing and car sharing, and there are many mobility companies these days. And it was mentioned that we need to identify as many use cases as possible. I don't know the situation of UK, but there are many mobility companies in Korea, but I don't think there are many companies that have profitable business models. And one of the reasons for this is because mobility is all about people and the movement, mobility of people, and we need to accurately forecast and predict the demand and supply. And if we can do that, this can become a viable business model, creating profit. And telco companies have a strength in that if you think of a telco company, we provide connectivity, and you might think that's our area and it's limited that, but actually we're involved in data. If we can provide anonymous data in a statistical way, we can provide statistical data on the movement of the population from one area to another. And if this is connected with the Kakao Taxi passenger data, and then we can identify demand and where that demand can come from. And this can be connected with the train services and bus services and get the traffic data. And such data can become a backbone for other services and allocating fleets at certain locations and at certain times. And when we look at AV technology, within a given scenario, implementing a use case, I think we have been able to develop technology here, but it is difficult to apply this in a city center. And just by dealing and processing data that comes out from individual vehicles and sensors will not be enough. Therefore, I think we need to consider infrastructure. And infrastructure analysis, that's not going to be easily done by individual companies, and in particular small companies. And I understand that UK has similar trials. Government-funded projects are being carried out in ITS, Intelligent Transportation Systems, and I understand that it's similar in the UK too. We have CVTX, and we carried out various ITS systems in municipal governments, and each municipal government, they have roadmaps to carry out ITS systems for 4 years, and large companies like KT are participating in these businesses to establish ITS. And ITS was mostly in the past a physical investment to physical infrastructure. But these days, we are working on production of data, such as vision data from cameras installed, CCTV cameras installed in intersections. And if this is provided in API as an open source, then many companies can create new businesses, and this will lead to a virtuous cycle. In addition, recently at our department at KT, we have precise data. We heard about the HD map from Kakao Mobility, and HD map is important, but on top of the HD map, you need to locate yourself, and there has to be precise location information on where you are and where your car is. Because we're a telecommunication company, we have telecommunication equipment installed, and we can get the absolute value and coordinates of that cell phone. And we can get information, and particularly the corrected location information of vehicles. And this will enable accurate positioning of vehicles, and we can contribute in adding precision to AV. And third, EVs and environmental friendly vehicles that was mentioned, and laying the infrastructure for charging stations. This is something that needs to be done by large conglomerates like us or the government. And KT, we have backbone infrastructure. We have many phone booths, and these days many people use their own cell phones. Therefore, almost nobody uses such phone booths, and these phone booths can be converted into charging stations for e-motorcycles and small vehicles. Another project that we're carrying out at the moment is about safety of EVs. There are many people who are concerned about safety of EVs, and we are monitoring the EVs to get the status information of the EVs, and we're working with the battery manufacturer on this, and we can collect battery data. And if this is integrated with the vehicle data, it can lead to a new service, and such data can be open to startups and small, medium-sized companies as a long-term plan. And Robert Evans talked about logistics, and I think there is a huge opportunity there. SMEs and startups, they work on algorithms and development of algorithms. But if this is to be applied in real logistics, large companies need to join in these activities. Thank you very much. So I have not been able to give Thomas Webster a chance to give his remarks. So let's hear from him.
So the first question about pushing and pulling, I thought, was a very interesting one. And I would suggest it is not so much a question of whether just to push or pull, but what should be pushed or pulled. And I would suggest that, for example, in terms of from an authority perspective, you want to push in a system of governance that can give market the certainty that they require on what they will need to do in order to release their product to market. That will then enable them to invest and pull it through. And also in the way that is pushed in that system of governance can help steer the opportunities so that they are supporting the needs that governance wants to build what they want from society. So if you want lower carbon emissions, then you can help push in the system of governance to steer the market towards more shared vehicle use to help lower carbon emissions, for example. So yeah, I was just thinking about that since that first one.
오케이, 감사합니다. 혹시 우리가 굉장히 스몰
So, as you know, we have a very small group of audience, but we do have people here offline as well. So, we would like to take this opportunity to take questions from the floor. And we also have from KC Motors, our advisor to KSAE.
감사합니다.
Thank you for your great remarks. And listening to the panelists, and also based on what was proposed by Professor Hong, I want to ask a question from the opposite side. Actually, my initial question was this. So large conglomerates, more structurized companies, when they enter into the future mobility area, they have sufficient cash, they have resources, and they have an organization to back this up. Small, medium-sized companies and startups, what should they be cautious about when they enter into this field? That was my initial question. However, I think this was covered by the comments made by the panelists. So, now from a different angle, you might think that this is high risk, so you should be cautious when you enter into these areas. What are some areas that you feel is a high-risk area that SMEs and startups should be cautious about? Is there anyone from the UK side that would like to answer this question? So, SMEs, when they enter into mobility business, what are some areas that they should be cautious about, that they should not do? So, some big don'ts.
I think one thing that they definitely should not do is make a distinction between being agile for software development and any operations on the road or in public spaces or with people where there is risk of harm. So SMEs do need to make sure that in their business model, in their plan, that they realize that they need to put much more checks and balances in place for physical operations that can cause harm compared to software development and system development, which can operate in a much more agile and dynamic way. And this is very important because it changes the forecast on how much money they're going to spend and how much resources they require to hit certain milestones.
예, 결국 그 스케일에
So I think it is about the control of risks and scale.
시간이 벌써 굉장히
So we have used up a lot of time already, and on the issues that have already been covered, if any one of the panelists want to add some additional remarks, please go ahead. Through the panel discussion, the issues that have been raised, they're really thorny and difficult questions and issues. Mobility and AV, it's an interdisciplinary area, and as many of our panelists said, it's very difficult to forecast the future. There are so many unknowns, uncertainties, and we need to identify a business model within the limited time. It's almost an impossible task that we have at hand. And Professor Ju has written down a lot of items, so I think we should hear from him.
First of all, we only have 15 minutes left, and so I think maybe this is going to be my wrap-up comment. And so for the panel session, I think that we really want to find the right direction, right model for creating a cooperative framework between Korea and the UK for future mobility. And as you are well aware, people who are working in the mobility area, they first look at the US or Japan or Germany, and they know these markets very well. And it's because mainly there are global OEMs and large companies there. So I do have to say that we don't really have a high awareness when it comes to the UK. But for me, I think UK has enormous potential, and they're really the forerunners when it comes to proprietary technology. And we already heard that during the morning and afternoon presentations. And of course, the people who know, know. And you have Jaguar, Land Rover still, but we still have Bentley and Rolls-Royce, and all these companies are legacy. They come with rich tradition. And I want to really emphasize that UK would be a right fit, a great partner for Korea. And because UK has a well-advanced financial services market, they're very savvy, and at the same time, they have a great foundation for startups to really grow and prosper. So I have to say that UK is an ideal partner for Korea, and I really support the collaboration because together I believe that we can really deliver great success and good results. And so I think that Korea should study UK more and truly understand the competencies and capabilities that UK has. And so I think that Korea, UK government, government to government, there's going to be many things that they want to cooperate as well. So not just AV, but also e-mobility and also connected mobility in these areas. Korea is creating a lot of test beds. And I think that the two countries, Korea as well as the UK, and I think we heard from Connected Places Catapult, the test beds that you have in UK. So I think between the test beds, Korea and the US test beds, we can also find some sort of cooperation framework as well. So maybe the governments of our two nations could take the initiative and also make this happen as well. So I think really the cooperation between the test beds would be very promising. And also the private sector cooperation as well. Of course, when private sectors get together and you understand where you are, what you're doing very well, then it's actually very easy to build cooperation. But I think really cooperating on the business model is very critical as well. And in a very short period of time, I think that you really want to sit down and discuss the business models that you are envisioning. And at the same time, there could be some common services, but at the same time, some services would be unique to our respective nations. But then if we can actually bring our ideas together, then we can create a critical mass so that we can actually increase the market size. And I think bringing scale to the business model is very critical for success. And so I really believe that the private sector will actually meet more often so that they share their business ideas so that we can actually find a very common ground going forward. Professor Ju, thank you very much for your kind remarks. I think to reciprocate, I think we would like to invite And in respect to the government-to-government, who would take the lead to talk about the government-to-government cooperation on the UK side? Anyone?
로봇 코멘트 해주실 수 있나요?
Robert, can you provide us with some comments?
Robert, can you hear us? If you can,
I can. Yes. Yes, I agree that it would be very good for there to be government-to-government cooperation. We have the support of the British Embassy for the event here. Oh. Yes, I can hear you. Can you hear me?
Yeah, I can hear you very well.
Okay. Yeah. So. Yeah. Yeah. So as well as that, we have a strong interest to link up between the UK test beds and the Korean test beds. So through Zenzik, who coordinate test bed activities. If we can find common ground on regulation and the testing of vehicles in controlled environments, that would be very helpful. This is also at an engineer-to-engineer level, because it's tremendously efficient if, in a motor industry context, the engineers can engineer to common standards and common agreed standards. So this I think should be a primary objective. I think we have opportunities to cooperate on technology, definitely on regulation, business models, and consumer acceptance as well. If we can mirror trialing activities in our two countries, we can share information about customer acceptance and business models. A final area I'd like to raise is that of insurance. At the moment, for a city to deploy a scheme or for a fleet operation to deploy automated vehicles, there is a question about the insurance and who carries the insurance risk and how that is managed. I think there's a role. We have a lot of small innovative companies looking to bring automated technology to a wide range of applications. In the UK, we have many different vehicle manufacturers, from buses, refuse collection, cars and trucks, and an interested supply chain to automate those vehicles, as well as to automate pods for transport applications. So we don't have one large, big OEM as you have in Korea with Hyundai. So we have this dispersed supply chain on the automotive side and a set of companies that are interested to automate those vehicles for niche applications. When they come to deploy, there's a question of the host, the technology company, and how risk is managed, and common frameworks around that ease the process of insurance for early fleet deployments would be something I think that would help the market grow and develop. So I'm interested to see if we can share insights and best practice in that area, as well as regulation, as we've discussed.
네, 감사합니다. 마지막 남은 시간은
So during the remaining time, we will hear the closing remarks. If any of the panelists would like to provide their closing remarks, Dave Williams or Thomas Webster, if you have any closing remarks.
Yes, I'd just like to say, although I could talk a lot about connected autonomous vehicles. I just want to reflect on those other comments that the future of mobility is not just limited to that. And we are doing a lot of work in the UK outside of connected autonomous vehicles to get more efficiency through digitalization, to help connect people with public transport, and to help decarbonize, make transport more economical and more environmentally friendly. So there is lots of opportunity there as well. Thank you.
네, 감사합니다. 처음에 발표.
So I believe that our panelists here, they have presented and they didn't have an opportunity to talk. So who would like to go first?
모빌리티 산업.
I think that mobility business is similar to smartphone industry 10 years ago when smartphones initially were adopted. So just as Professor Chu said, we need to do out-of-the-box thinking. We should not think just from the framework of auto industry and AVs and taxi services. If we are able to break away from this framework, I think we can create a business and industry that meets the unmet needs in the market. And this will lead to explosive growth for mobility. And mobility, it doesn't know national borders. The entire world is seamlessly connected. So not just with the UK, but we should expand this gathering to include global networking and connecting with various countries. And I hope that this can develop into a international gathering.
통신선의 딜레이.
Next, unfortunately, it took me a long time to understand the delay, and unfortunately, we have run out of time. So this is the second Korea UK Future Mobility Conference. Despite the ongoing pandemic, we were very fortunate that we had so many people helping us to make this conference possible. I was very happy to get great insights from our 4 panelists in Korea and our 3 panelists from the UK. And thank you very much for staying with us till the very end. So my deepest appreciation to the audience, and also especially people who are joining us not virtually but physically here. Thank you for giving us your time. And on this note, I would like to officially close the Korea UK Future Mobility Conference. Thank you and have a safe journey back home.